Good morning. My name's Casey White, and I'm the director of the Polar Research Board and the Board on Atmospheric Sciences and Climate, which is the group holding today's open session on Helene floods, Los Angeles fires, and Phoenix heat, lessons learned for a more resilient community. Thank you for joining us here in the room and online. This is the second part of a workshop. Yesterday, we heard 2 case studies focused on Phoenix extreme heat and the Los Angeles wildfires, looking at the various response and lessons learned for the scientific community that we can use to bring forward. Today, we're pleased to have a panel examining the Hurricane Helene in North Carolina floods and response there. I invite you all to participate. We are looking forward to hearing participation both in the room and online. Next slide, please. We are encouraging discussion and using the tool Slido to help facilitate that. So please enter this and add your questions. Feel free to upvote or downvote or engage this way so that our speakers can have a robust discussion and take advantage of all the expertise that we have with us here today. So I am pleased to hand this over to our moderator for the first session, Kevin Reed, who's at Stony Brook University and a member of our Board on Atmospheric Sciences and Climate. Kevin.
All right, well, good morning. As was just mentioned, our morning session will focus on the impacts of Hurricane Helene, particularly in the Western North Carolina region. But in order to kind of get us started and provide a little bit of a background on the storm itself, Hurricane Helene formed in the Western Caribbean Sea, becoming a tropical storm on September 24th. The storm moved north up into the Gulf with impacts on Mexico and other Caribbean islands before eventually moving into favorable environment for intensification, including the very warm Gulf waters at the time, which led to a peak intensity eventually of about 135 miles per hour. On September 27th, Helene had become a Category 4 storm before making landfall in the Big Bend region of Florida. It became the strongest storm to do so in that region since at least 1900. Some of the impacts near the region of landfall was a storm surge of over 10 feet in regions of in areas of the Big Bend region, wind gusts that approached 100 miles per hour throughout the Florida region, as well as widespread rain. As Helene continued to move northward and inland, strong winds and rain extended well inland across Georgia, South Carolina, Tennessee, and North Carolina, which will be the focus of our discussion today. The rainfall, a little bit, we're going to hear more of this, of course, from our speakers this morning, but to just give a couple high-level aspects of the impacts, particularly in the Western North Carolina region. The rainfall from Hurricane Helene and particularly heavy rains in a predecessor rain event in the days leading up to the storm led to damaging floods throughout the North Carolina Western region. Rainfall amounts of up to 30 inches occurred in mountainous regions, and this led to widespread flooding along rivers and streams, as well as landslides. Altogether, Hurricane Helene led to at least 176 direct deaths, with over half of those occurring in North Carolina, as well as many more injuries. Over 7 million customers lost power throughout the Southeast. And according to the NOAA National Centers for Environmental Information, Hurricane Helene resulted in over $78 billion in damages, making it the seventh most costly hurricane in United States history. Including these damages were due to a variety of reasons, including tens of thousands of homes that were destroyed or impacted, roads that were washed away, and water treatment plants that were impacted directly. So as I'm going to turn it over to our panelists in a second, but as we do that, just to provide a little bit of background of what we're hoping to discuss is we're hoping to learn in the next hour or almost 2 hours a little bit more of a broad understanding of the unique characteristics of Hurricane Helene's dynamics, as well as particularly in the impacts it had in Western North Carolina, as we focus on the first few talks, particularly around the extreme rainfall observed, as well as discuss the compound nature of the event and what were some of the contributions that led to such severe flooding throughout the region. Particularly as the impact of not only the large scale of rainfall, as I mentioned, of up to 30 inches in some regions, but also the topography and infrastructure failures that were experienced. We're going to talk a little bit about some of the opportunities to plan and prepare and respond to such events in the future. And also start to look at what are some of the interactions and contributions from the atmospheric science and hydrometeorological sciences that can help to improve or the predicting of these type of events in the future, as well as to inform planning and investments in more resilient infrastructure and communities going forward. So with that, I would like to actually welcome our first panelist of the morning. Our first panelist is Dr. Ken Kunkel, who is a research professor emeritus at North Carolina State University. So Ken, I will turn it over to you if you're able to share your screen.
Okay, can you hear me?
We can hear you.
Okay, let me pull up my presentation. And okay, can you see that?
Not yet. I think, do we have to stop sharing on our end, or did we already?
We see it online.
Oh, yeah. Okay, we can see it now. Yes, perfect. Thanks, Ken. Take it away.
Okay, thanks for the opportunity to talk about Helene. I'm going to concentrate my remarks on North Carolina, talk about some impacts and my personal experience, also share some rainfall statistics and some of the characteristics of the rainfall, and finally provide a historical perspective on the rainfall. So there were 107 fatalities in North Carolina alone, $60 billion in damage. For example, 74,000 homes were damaged. Of those, 9,000 severely damaged or destroyed. There was catastrophic damage to a wide range of infrastructure. For example, the Asheville water system was severely damaged. Around 100,000 people had no running water for 19 days and no potable running water for 53 days. My wife and I were two of those 100,000 people. And in addition to having no water, we had no power, no cable internet, no cell service for 2 to 3 weeks. There were more than 2,000 landslides in Western North Carolina. This is one of the worst events in U.S. history, according to the USGS. This is a picture of flooding. On the right-hand side, this is from the Asheville River Arts District, a popular tourist destination, just to contrast with a non-flood picture on the left. This is a picture of a creek, very shallow creek, outside of the subdivision where I live, and you can't really see except in the far left, the creek. Usually runs less than a foot deep. This is what it looked like the morning after Helene arrived. It's probably several hundred feet deep. You see the rushing water, perhaps, or several hundred feet wide, maybe 20 to 25 feet deep. There was a mobile home that was washed away about a quarter of a mile upstream from here. And unfortunately, one person lost their life in that event. Some of the rainfall totals, highest amount was 31 inches at Busick. Mount Mitchell had 24 inches, Bear Wallow Mountain, 20 inches. I'll come back to that station in a minute. I had 15.6 inches. According to NOAA Atlas 14, that's more than a 1,000-year return interval event. The storm had high-end tropical storm intensity when it reached the state. This was a compound event. A stalled front caused excessive rainfall before Helene's arrival. An all-time record flood levels were set on the French Broad River. Previous record was 1916. And on the Swannanoa River, there's a high water mark recorded from 1791, and this event exceeded that. This shows rainfall totals from the CoCoRaHS network, a network of volunteer observers across the country. The highest amounts here, and you see a number of amounts on the kind of the right-hand side of the screen that were more than 20 inches, quite a lot of numbers above 15 inches. The highest amounts in this event were on the eastern escarpment of the Appalachian Mountains, essentially on the right-hand side of this graphic, because of the easterly flow around Helene as it moved into the area. This is a radar loop, and it will show you this predecessor event that occurred, the stalled front, and you see rainfall occurring over North Carolina here in the upper top for many hours, and only now do you see Helene entering the picture. And it barrels on shore, moves up through the southeast, and produces another period of very intense rainfall before it all ends. Here's some flood hydrographs from both the French Broad River and the Swannanoa River. Just like to point out how high these levels are, several feet above the major flood stage level, and the rapid rises that occurred before the peak. 15 to 20 foot rises in the 12 to 24 hours before it hit the peak. This shows the time series of rainfall from this station, this Bear Wallow Mountain Station, which is operated by the North Carolina State Climate Office. This is a 4-day period. You see sorry about that, steady rainfall for many hours on the 25th and the 26th. In fact, almost 9.5 inches fell in the 36 hours prior to Helene's arrival. And then once Helene entered the picture, another 10.5 inches fell. In addition, the highest rainfall rates occurred at the very end of the storm. You see this 2.5 inch amount during 1 hour. And if you look at this 3-hour period between 6 a.m. and 9 a.m., 5 inches had fallen. This is a kind of curiosity or a notable point because the USGS uses 5 inches in 24 hours as an empirical threshold for landslide occurrence. At this station, 5 inches occurred in 3 hours after 14 inches had already fallen in the event. I published a paper back in 2019 in response to Hurricanes Harvey and Florence, looking at the largest multi-day rainfall events over large spatial areas. And this shows a ranking of events over 4-day period, 4-day accumulations over 50,000 square kilometers. And this is the graph from that paper. Harvey ranks as number 1, and by a large amount. Florence also is notable. It's ranked 7th here in this ranking. I updated this analysis through 2024 and redid this graphic, or at least showed other events that pop up now in the very top of the ranking. Imelda 2019, this was in the Northeast Texas coastline. Sally in 2020, which affected the Florida Panhandle. And you see Helene also ranks quite highly. If we re-ranked all these now, Helene would rank number 11 across the nation over this period from 1949 to 2024. This compares rainfall from 1916, which was the previous record holder on the French Broad River in terms of flood peak, with 2024. The pattern of rainfall is very similar, a little bit higher amounts in 2024 than 1916, at least in this analysis, but there were far fewer stations in 1916 to base the analysis on. If you look at point rainfall amounts, there were comparable amounts in 1916, Altipass 31 inches, and several stations had more than 20 inches. The 1916 flood was also a compound event, back-to-back tropical cyclones. And although the rainfall amounts were comparable, the two tropical cyclones were separated by a week, giving a chance for the rivers to kind of drain, whereas the frontal event occurred immediately prior to Helene. So sum up my remarks here, the meteorology, this was a compound event. A stalled front and upper level trough occurred, followed by Helene. These were independent meteorological systems, but they were fueled by the same very moist tropical air mass. The rainfall amounts were historic. Area average multi-day rainfall was nationally one of the largest in the last 75 years, and on a par with Florence, just a little bit below Florence. Highest rainfall rates occurred at the end of the event, at least at this one station. And I hypothesized that this greatly amplified the peak river stages and the associated impacts. And this station is located close to where some of the most catastrophic damage occurred to infrastructure and to loss of lives. Thank you again for the opportunity to talk to you all about this event.
All right, thank you, Ken. So we're gonna keep questions for the discussion period with all of the panelists coming up after the brief talks. So next, I'd like to welcome Dr. Kathy Dello, who is the state climatologist of North Carolina and the director of the North Carolina State Climate Office. Take it away, Kathy.
Thanks, Kevin, and thank you to the board for having me here, and thanks for covering this event. It's been just over 7 months since Hurricane Helene hit North Carolina, and I promised myself that every chance I got to speak about it, I would, because we need to keep reminding people of what happened. And as Brad mentioned yesterday, we keep having so many disasters that these things can be lost in people's memory. So thank you for covering it. I also like going after Ken Kunkel because I don't have to cover as much about the precipitation. And I also like following somebody who had a real lived experience during the storm. I sit in Raleigh, North Carolina. That's about 4 hours to the east of Asheville. And I run a state climate office of about 12 people. And that day, we are sitting on our computers and we weren't doing any of the work that we were supposed to be doing. We're seeing the data come in all day from our Econet stations, which Ken showed, but also some of the numbers that we were seeing and trying to piece together what was actually happening up there. And at that point, we didn't realize that we couldn't communicate with folks up there. We were reaching out, they weren't writing back, and we thought, oh, of course, they're going through a hurricane right now, but they were absolutely cut off from communication for a number of days, as Ken mentioned. There we go. So the weather forecast was spot on. It was a very good weather forecast. This is Thursday. This is the Greenville Spartanburg Weather Service office, and they say this will be one of the most significant weather events to happen in the modern era. And it goes on and talks about absolutely everything that did happen in Helene. We all saw this pop up. I saw this, folks around North Carolina saw this, and it's still difficult to imagine what this looks like on the ground. So it's about 6 p.m. in Raleigh, and I'm walking home, and it just feels heavy outside. It feels very tropical. And I stop and I pull out my phone and I emailed 3 people up in Asheville who are not weather or climate people. Not everyone in Asheville is weather or climate person, and said, I need you to take this storm seriously. It's no joke. And still, the forecast was great, but people either didn't get the info or didn't receive the info, or you know, it's okay to reach out to 3 people, but we needed hundreds and thousands of people to get this forecast. I won't dwell too much on the rain because we just talked about this. My team puts together a rapid event summary after every named storm. We did this with Helene. It was out Monday morning and picked up by pretty much all the national news outlets. It's been viewed, I think, 400,000 times now at this point, but we put together a really quick analysis of the precipitation. You see it was heavy in Western North Carolina, but we did get some rain in the central part of North Carolina, the Piedmont area, Raleigh and whatnot. But I do want to point out the North Carolina coast. And just 2 weeks prior, this little system popped up off our coast. And the next name on the list was H. Helene. And at 11 a.m. on that Monday morning, it looked like it might get a name. It looked very close to having the characteristics that we needed. The wind speeds were there. it didn't. So potential tropical cyclone 8 dropped 20 inches of rain on coastal North Carolina. And then 2 weeks later, we had Helene. So back-to-back extreme events across the entire state. Now, Ken mentioned this, tropical systems have caused flooding before in Western North Carolina. We got lots of calls saying, well, Asheville's a climate haven. We didn't expect this. We knew that this had happened in the past, and it had actually happened in 2021. It was a much smaller storm, Tropical Storm Fred, flooded Canton, North Carolina here. Canton over there is a mill town. 6 people died in this storm. And the mayor of Canton, who is a friend and a colleague, says Canton's been hit by 2 hurricanes in the past 20 years. Charleston, South Carolina has not. So new Hurricane Alley, Canton, North Carolina. But we've seen this in the past, 1916, 2024, we had Fred, and then we had those 2 hurricanes in 2004. So we knew that this could happen. There was wind too with this storm. That 106 mile per hour gust is Mount Mitchell. That's a station that my office runs. That 87 is Frying Pan Mountain, but wind speeds were high across the entire state. And I want to point out the confirmed tornado way in the eastern part of the state, that's Rocky Mount, that was an EF3 tornado. Massive storm, and I remember when that line moved through. It was moving through just as the same time that NC State was emailing us and saying, we're still having class. So the timing there was also a little bit off in thinking about communication. Now, since we're here in the Board on Atmospheric Sciences, I wanted to point out the importance of observations. We get really jazzed about modeling and fancy things. You can't do any of it without good old-fashioned data. And my team runs the North Carolina EcoNet, 45 stations around North Carolina, really high quality 1-minute data. What you're seeing here are the maximum surface wind speeds. The black line is Asheville Regional Airport. So that's kind of your ASOS station, what you would normally go to. The blue line is our station just down the road in Fletcher, literally just down the road. And you can see that when the NOAA station popped off, or the airport station popped off, that we were able to capture some of that data, some of that really necessary, crucial data. People do not like funding monitoring, but it is so, so important. And then our friend Trisha Palmer at the Weather Service Greenville-Spartanburg said, we were watching your data and we were able to warn people because of it. Now, this is Appalachia. It's rural, it's remote. Maybe you've been to Asheville, but these are tiny communities in hollers. A lot of people are really stressed on housing. A lot of folks can't find affordable housing near the place they work. We have people on Medicaid without health insurance, living below the poverty line, and they're elderly too. So a lot of folks said, well, why didn't people just leave? Well, some folks just could not afford to leave or were unable to leave. Asheville is the population center up there, and even Asheville's not that big of a city. And that really rural nature of the area has made it really complicated to understand the full impact of Helene. We're still learning things today. We couldn't get access. Like I said, communication was down. The communities are all disparate. They were working together. And some of the strongest stories that you hear post-Helene are of people coming together to help each other out. It's not the science. It's not the data. It's neighbors helping neighbors. Now, we know that there are widespread home losses up there, and 92% of homes with flood damage did not have flood insurance. Not that surprising, right? But we know it can flood up there. Big hits to our infrastructure. I-40 to Tennessee is now open in 1 lane, but essentially the road fell off the mountain. And we are working with the North Carolina Department of Transportation to help them understand future precipitation and how they should build their infrastructure to meet some of those more frequent Helenes. And there's other things going on. We talk about compound hazards and compound disasters, but everything is more expensive. And this is a tourist area. Please visit Asheville if you can. It's open, buy things, spend money, eat dinner, but they are seeing a massive economic hit from the loss of tourism. And we can categorize the damage in all the categories: agriculture, transportation, utilities, natural resources. Our friends at Duke Energy were just amazing at getting that infrastructure back up and running. And we were watching our weather stations. A few of them went offline and lost power for a number of months. And on Christmas Eve, the last station came back online, Mount Mitchell, and it had been recording data the whole time. It just wasn't talking to us in Raleigh. And I know we're going to talk a little bit about compound hazards, and Ken definitely touched on one of the compound natures of these hazards, but we were really dry before Helene. So this is the Busick station. This is the station that got that 31 inches of rain. And it was a dry summer. Some of these little storms passing through, but the Blue Ridge Public Radio folks called me just a few days before Helene and said, Kathy, let's talk about drought. Looking at the forecast and thinking, well, we might not be talking about it for very long, but we were in drought conditions. The huge jump up is Helene, and then immediately after we dried out again. So we swung between wet and dry. We talked about fires yesterday. There are a lot of trees on the ground from those wind speeds. It's been very, very dry up there, and we've had a number of fires already. So first rain and then fire chased people from their homes in North and South Carolina. It has been a shocking and distressing 7 months for these folks. And there's a lot of research that we can do as a community to help make these communities more resilient to what is coming and what will happen again. So just a quick summary. This was due to physical and social factors. It's never just weather or climate, and we know that. Observations are so important, and we can't do our good science without it. The forecast was excellent, but communication is still a challenge. I knew what that forecast said, and it was still tough for me to picture how bad it was up there. And the compounding nature of these hazards creates a bunch of additional challenges for us, especially when it comes to short-term recovery, long-term recovery, and long-term resiliency. So thank you for your attention.
Thank you, Kathy. So next, we're going to move to Dr. Amir Agakochik, who is the Chancellor's Professor at UC Irvine, and is going to talk a little bit more about the impacts of flooding and compound events. Amir, can you share your screen?
I'm sharing now. Can you see my screen?
Yeah, we can see it on Zoom. Just give us 1 second as we swap it in the room. Yep, we are good to go. Take it away.
Good morning, everyone. Thank you for the invitation. Delighted to be with you. And today I'm going to talk more about the compound flood processes and risk assessment methods and how we can update the way we look at compound events. Ken and Kathy provided a great background, so I'm going to jump into these processes involved with multiple hazards. So in coastal areas, I'm going to focus more on coastal environments where you can have multiple flood drivers. During hurricanes and also atmospheric rivers, you get extreme precipitation and also surge. So ocean water level will be above average, and they interact with each other, of course, in coastal areas. Fluvial flow or river flow drains toward the ocean, and that's where these three different flood drivers interact with each other. So what in coastal areas, we have also population centers. So in addition to these physical drivers, we have some other processes that contribute to risk. For example, groundwater extraction, oil extraction, and lots of other activities contribute to land subsidence. And land subsidence can increase relative sea level and the effect of intensify the effect of storm surge. There are many other non-climatic processes that can have an influence on compound floods. So what happens during a compound flood event in a coastal area? So let's say this is a cross section. We have a flood peak with discharge Q. So this is the river discharge draining toward the ocean. If ocean water level is low, let's say you have low tide situation, then you have high gradient. The amount of water that can drain to the ocean is a function of gradient. So if you have low water level, then water can easily drain to the ocean. But what if you have high tide situation or extreme surge? So the lower the gradient, less water can drain to the ocean, and under extreme cases, river flow can even go backwards, and that can make flooding a lot worse. And this happens all the time during compound floods, especially during hurricanes and atmospheric rivers in the West Coast. Now, how do we bring this into our risk assessment frameworks? If you look at our current guidelines, one of the gaps is that we have models that can simulate these processes. We have hydrodynamic models that can accurately simulate water level. But for our risk assessment, let's say design of infrastructure systems, we need to have risk assessment guidelines that account for these drivers. That's where the gap is. If you look at, for example, USGS flood frequency guidelines that we use for infrastructure design, these processes are not included. So the ocean water level is not dynamic. So a few years ago, we looked at common methods for risk assessment, like the reliability equation or failure probability equation, which is here. And we kind of extended it to multiple hazards. I don't go into details, but this allows us to bring in the effect of multiple hazards from a statistical perspective, consistent with the methods we use for risk assessment, infrastructure impacts, and so forth. So I show you examples from near North Carolina, not exactly where Helene happened. These are some coastal environments where you have these drivers interacting with each other based on historical data. So this is one place where you can see the y-axis is failure probability, the x-axis is time or design lifetime, let's say levees or seawalls or any infrastructure that you're interested in. The black line is coastal flood risk based on USGS guidelines. So one single hazard. This is the most common driver we use for risk assessment currently. So red line is the effect of compound event if you bring two drivers together, actually three drivers together. And if you look at the difference, you see that if you ignore the compounding effect of drivers, you underestimate the risk of flooding by 10 or 15%. This method allows us to bring in the effect of sea level rise. That's the purple line. We can replace historical sea levels with future sea levels and reevaluate. The interesting thing about this approach is that it's consistent with the way we do risk assessment for critical infrastructure systems. By the way, when we say failure probability, this is not physical failure. This is failure from hydrologic perspective. Let's say you have a seawall and you have failure probability of 100%. This doesn't mean the wall fails. It means water goes over. Now, we can translate that, of course, to physical failure. I'll mention that in a moment. We have looked at these processes in different places around the country, so the pattern is more or less the same. If you ignore compounding effects, you underestimate the risk. The level of underestimation is different in different places, but the general story is the same. But coastal systems are very different. We have places like Alaska where there is a lot of open space, nobody lives there. If because of sea level rise, we leave some of our flood coping capacity or estuaries, another one will evolve. But we have some other coastal systems where we have population centers. It means we have hard boundaries. And if, let's say, in future, we lose some of our flood coping capacity because of sea level rise, that capacity is gone forever. This is an example of an area on the right where we have all these population centers. So what I mentioned up to now is statistical approach, and the failure probability is a statistical failure probability. There are methods that we can use to link failure probability to physical failure probability of levees or seawalls and other infrastructure systems. I don't go into details, but there is this reference paper where basically we translate statistical failure probability on the right to physical failure probability on the left using a physics-based model. But I'm going to skip that. So in coastal areas where you have these multiple drivers, we also have a lot of facilities. For example, 400 federal facilities in coastal areas. These are some simulations of, for example, Langley Air Force, Norfolk facilities under expected sea level rise and future hurricanes. Future hurricanes here are based on statistics of past hurricanes. And as you can see, we expect significant impacts in a lot of our military infrastructure. And I mentioned briefly land subsidence. If you look at the rates in the East Coast, in many places, the rate of land subsidence is kind of similar to sea level rise. So land subsidence is kind of making sea level rise worse by a lot. This relative sea level rise, again, plays a big role in significance of compound floods and in underestimation of current methods. A little bit about extreme precipitation. My colleagues mentioned about the amount of rain, and I want to talk about non-stationarity a little bit. If you look at the statistics of extreme precipitation in different parts of the world, we have a kind of increasing trend in extreme precipitation. These are different parts of the world, global averages, North America. And specifically, when you look at the US, in many places, especially Northeast, there are places where we have significant statistical trend. The blue dots are where we have strong positive trends, and you get signals like this, where your hourly or 2-hourly precipitation is going up significantly. We have our own method for analysis of extreme precipitation using non-stationary method. We call it PRONEVA. I'm going to jump into the results. So if you look at different parts of the US, especially coastal areas, we have places where rainfall intensity, duration, frequency based on current methods. Current methods is the gray line in these places. IDF curves are basically methods, again, we use for risk assessment for design of critical infrastructure. If we use a non-stationary method, which is not a common practice right now, you get the red line. And in most places, red is above gray, which means we underestimate the risk of extreme precipitation if we ignore the non-stationary patterns. And specifically here, we show how a 100-year event changes if you bring in non-stationarity. So for example, in places like Sacramento, a 100-year event can change into a 60-year event if you ignore non-stationarity, if you account for non-stationarity. So here's one specific example. This is from San Francisco, but the same pattern applies everywhere. So blue line is rainfall in IDF curve from NOAA. So this is what we use primarily today for design purposes. So the y-axis is precipitation intensity, x-axis is duration. If you bring non-stationarity and extreme precipitation from future climate models, you get the red line. And you can see that there are methods to convert, future return period to historical version. So today's 50-year period return period event will turn into about a 30-year event. So this method is now part of a manual of practice. It's not a code. It's one level before code. It's an ASC, manual of practice. But ASC is trying to develop a code based on this concept. And there are other compound events that are more complex. I don't go into them, but yesterday there was a session about fires, and extreme precipitation and fires are related, both because of post-fire activities, but also pre-fire. I want to show one slide and wrap up. In the West Coast, at least, if you look at our worst fire years, these red dots are our fire years. They all happen after extreme wet years. You need wet years to have a lot of vegetation growth and fuel for future fires. So there is this complex pattern of interactions between extreme, Kathy also mentioned extreme wet and extreme dry, and fires are sometimes another kind of hazard that connect them together. With that, I'd like to stop. I'd be happy to take any questions you may have. Thank you.
Yes, thank you, Amir. So as a quick reminder, we will take questions via Slido, the link that was shared. So please start to populate that with questions before our final speaker here. So we're going to move to kind of from the compound impacts of flooding that Amir provided a broader context of, and then now start to look a little bit around the opportunities for planning and resilience and how to work with communities. And so I'd like to welcome our next panelist, which is Chris Campany, who is the Executive Director of the Windham Regional Planning Commission, and will provide a context of another mountainous region of the United States that experiences similar precipitation type events to those that we've been discussing with Hurricane Helene. So Chris, are you able to share your screen?
Yes. Let's see, unmute. Can you hear me okay?
Can hear you perfectly.
Okay, and I'm going to hit share. Let's see. All right. Can you see the presentation?
No.
Okay. Let's see. You've got it loaded up there.
Yeah, we can share it, and then you can just say next slide.
Yeah, is that okay?
Yep, we'll do that right now. Just give us
Okay.
1 second. Okay, so just go ahead and say next slide when you
Okay.
want us to
Right
advance.
there. Perfect. Just stay
And you're
cover
good to
right
go.
there. Okay, you go to next. Perfect. So my name is Chris Campen. I'm Executive Director of the Windham Regional Commission in Southeast Vermont. As you may tell from my accent, I'm in Southern Vermont, actually. I grew up in Southwestern Virginia, a little town called Abingdon, just north of Western North Carolina, just south of Eastern Kentucky and West Virginia. And so what happened during Helene is near and dear to my heart. And I worry that the flooding that's been happening in Eastern Kentucky and Southwest Virginia over the last 5 years hasn't gotten as much attention as it should, as well as West Virginia. But our towns in Vermont, there is effectively no county government. So Vermont's 11 regional planning commissions provide an essential link between local, state, and federal government. Our largest town in our region is Brattleboro, the population of 12,000. Our smallest town is Somerset with a population of 6. In Vermont, because we are such a small state, the Regional Planning Commission directors serve as points of contact on different programmatic issues. I'm the point of contact on emergency management and disaster recovery, as well as conservation. And then also in Vermont, the Regional Planning Commission serve a local liaison role. During disasters, we help communicate up to the State Emergency Operations Center situational awareness from local government. Can you go to the next slide? So just a brief overview of Vermont, just a reminder how small we are. I should have done an overlay of Vermont over Western North Carolina. It occurred to me as I saw that map, what it might look like. So we have a total population around 643,000, median household income around 81. Poverty is 9.7% overall and generally consistent across age groups. We have a relatively small number of total households, about 280,000. Total housing units, only 334,000. Median age is 43.7, and we have a relatively older population. And our particular region is one of the oldest in the country, I believe. Go to the next slide. So we've had a number of federal disaster declarations, 13 since 2019. These are weather related. This does not include the pandemic. And there was a report from Vermont Digger. There was a database listing 20 major disaster declarations for Vermont during the study's time frame between 2011 and 2023. The vast majority are severe storms leading to floods. That means despite Vermont's modest size, we're 45th in land area for the states. Only Arkansas, Iowa, Mississippi, Oklahoma, Tennessee, and California were issued more federal disaster declarations. And our treasurer, Mike Pichak, noted that since between 2011, when we had Tropical Storm Irene, through 2024, and this number is not a total yet, we've received more than $680 per capita in federal disaster aid since 2010. Next slide. And these are the state hazards ranked per the state hazard mitigation plan. While inundation flooding is certainly a concern, our bigger risk is actually fluvial erosion. Landslides are also down there, since we're talking about flooding and flood related disasters. I wouldn't be surprised if after the recent events, landslides don't creep up that list a bit more. Go to the next slide. As a reminder, fluvial erosion is when the banks actually erode or channels migrate. Go to the next slide. And the inundation, the erosion slide there, you don't have to go back. That was Plainfield, Vermont, after the 2024 flooding. And then, of course, inundation flooding. And, you know, the irony is, in my world, because of just the sheer violence of the fluvial erosion, the erosive flooding, it almost feels like you get off lucky if you're just suffering from inundation flooding. Go to the next slide. And then, of course, as I mentioned, landslides are becoming I guess they've always been an issue, but the intensity of rain events and the sheer quantity of water falling on the landscape, I think we're seeing more and more landslides, and I think Vermonters are generally becoming more aware of their risk that they pose. Next. And of course, we've had more rain over time, and we're also seeing higher frequency and higher intensity events. Go to the next slide. And so now, just comparing some events, 2011, we had Tropical Storm Irene. That was kind of the flood of record, of at least within recent living memory. We've had worse in the past, but that was kind of the benchmark. That after Irene, Vermont made a lot of changes to how we prepared and responded to flooding, including creating an awesome rivers and roads program that everybody who works on roads in Vermont, you get training in rivers and roads, how the two interact, including river science, geomorphology, also biology. And then the local liaison function of the regional planning commissions during Irene, there was so much damage throughout the state. The regional planning commissions really had to assist our municipalities with their recovery. So it really changed a lot of different flood preparedness and recovery dynamics in the state. And then 2023 came, and that you see the precipitation totals there on the right, but it was smaller in overall geographic scale and than the prior than Irene, but up in that kind of north central Vermont, you can see that corridor. That's where we have a few small cities like Barre and Montpelier. Montpelier is the state capital. And so in terms of impacts on individuals and households and businesses, in some regard, and because it did hit kind of the overall state civic center, it in some ways it did more damage to total numbers of people than Irene did, I would say. Go to the next slide. And this is we're participating in national water model discussions along with Missouri, and I just wanted to show this was the monthly for the month of July. You can see that many areas of the state received up to 20 inches of rain for the month as a whole, and the whole discussion we've had before about antecedent moisture conditions, kind of setting a stage for worse exacerbated events. That is, you know, here whenever we start having a wet month, I know that just because we've had a drought doesn't necessarily mean things are going to be better as they saw in Western North Carolina. But I get incredibly nervous now, especially as we approach tropical storm season, when we have saturated soils at all. Go to the next slide. And then 2024, you can see it was a different pattern. So our area down here in Southeast Vermont, we were actually heading towards abnormally dry, and later we achieved moderate drought conditions. But you can see that the 2024 flooding, the early July flooding, hit a lot of the same area on the same day in the northern part of the state. So that just really added to the trauma that folk were experiencing. And then we had this really anomalous cell hit in the Northeast Kingdom, that area up in the northeast quadrant of the state. That I'm sure that storm was, I'm sure there's been studies on it. As I recall, there wasn't even anything on in the excessive rainfall outlook. As I recall, that night in the news, there really wasn't, much precipitation in the forecast, and then they just got hammered. I believe 2 people died in that storm. Go to the next slide. And here's again using a national water model. You can see the relative distribution of total rainfall over the state for the month of July 2024. 10 to 15 inches up there in that kind of mauve color. Go to the next slide. So in terms of public infrastructure, the damage was over $1 billion in 2023, several hundred million for 2024. But if you remember how small Vermont is, how few households we have, how few people we have, the impact on households, and this is just FEMA data, was pretty profound. 26.3 million was provided to 3,600 households as a result of the 2023 flooding. You can go on to the next slide. And then in 2024, funding was provided to approximately 1,400 homes or households. And that number was probably actually impacted by limits on how much FEMA can give to any one household over a period of time. But the point here is that, these numbers may not seem huge in kind of a larger national context, but for Vermont, I mean, this is a sizable, significant percentage of the population. Go to the next slide. And so, of course, our geography and our history of how we settled here exacerbates this issue. So I am not a meteorologist or a climatologist, but it's, it seems clear, and it's my understanding that, a lot of weather systems exit through New England, exit over Vermont. So in addition to our mountainous topography, we also have a settlement pattern whereby people settled around rivers and streams in order to generate water power and just ease of transportation through those stream and river valleys. So a lot of people set up, especially on alluvial fans at in these because just that land was more easily farmed, more easily settled. And now, of course, that's one of the reasons why we have fluvial erosion as one of our greatest hazards. Go to the next slide. And the big issue we're dealing with now is we were already in an affordable housing crisis. We had a number of people, not a huge number, but it didn't take many people moving to Vermont because our housing supply was so low to really exacerbate prices. Year over year, we've had a greater increase in home prices over the last few years than any other state in the country. I sit on the State Hazard Mitigation Grant Project Review Committee. We've got over 240 buyouts that have been submitted to FEMA for funding of the Hazard Mitigation Grant Program and the SWIFT Current Program. There's another 50 or so in a queue, and then we have another 31 properties that were awarded funding through a state granting program called the Flood Resilient Communities Fund, and that latter is covering buyouts that wouldn't qualify under FEMA rules because they weren't located in flood hazard areas or weren't damaged through landslides. And so these are cases where typically they either were destroyed or were at risk of being destroyed by fluvial erosion, because a lot of these areas that experience fluvial erosion are not in the MAP flood hazard areas. Go to the next slide. And I want to end on this. This is Vermont and New England have a particular challenge. So each of those little geographic units, those are all municipalities in Vermont, and then on the right, that's New England. And so generally speaking, go to the next slide. In Vermont, but also most of New England, we don't have county government as you would have it in other parts of the country. In Vermont, it's really limited just to the courts and the sheriff's department. The sheriff's department doesn't even cover the whole county. Municipalities subscribe to their services. So that means whenever we have a declared disaster, when FEMA comes in or when the state's trying to assist municipalities, or just municipalities assisting themselves, those decisions are getting made in each of those 250 different units. And if you think back to that New England map, it's the same case throughout New England. And so we have no county scale disaster preparedness. We have no county scale emergency management director. You have emergency management directors appointed in each of those municipalities. And also, in the absence of county government, we have no way to aggregate public tax dollars between the municipal level and state level, meaning county scale recovery in terms of cash flow and public dollars is just not a possibility. Go to the next slide. And it's really hard to plan for future resilience and adaptation when you're in perpetual response mode, especially when your government is primarily volunteer run. Most of our towns do not have town administrators or town managers. They rely on volunteer select boards. In some towns, the only paid employees may be the road foreman, and then a couple of elected positions like town treasurer and town clerk. Go to the next slide. And we're heavily reliant on federal aid, both from a preparedness standpoint. You're relying on the emergency management planning grant. We use federal funding to help develop. It's really difficult to develop local hazard mitigation plans at a regional or county scale because each of the towns would have to adopt those plans at the same time, which is really difficult to coordinate. So each municipality tends to have its own hazard mitigation plan, and that is typically funded through either hazard mitigation grant funding or building resilient infrastructure and communities funding. Then, of course, there's response reimbursement through a federal disaster declaration, public infrastructure recovery through public assistance federal disaster declaration, and individual and household recovery through individual assistance federal disaster declaration. Go to the next slide. And of course, now we are starting to see cuts. So the Building Resilient Infrastructure and Communities program, BRIC, has been terminated. And we've seen news, I'm sure you've seen it in your local headlines about states, county government, local government getting funding cut. And that program has ostensibly gone away. Go to the next slide. And then we're starting to see they'd already been, the federal government had been telegraphing that they would like to get out of the disaster recovery and response business, turn it over more to state and local government. And so now I think the count is, I'm probably not going to be comprehensive, but we've seen federal disaster declarations denied over the last few weeks to Washington State, North Carolina, Kentucky, Virginia, West Virginia, Arkansas. I'm missing some others, but we're starting to see a change in posture. And that has huge implications, especially for rural areas. And I would say New England, it has particular exposure because of our governance structure. Go to the next slide. And then you may or may not know that when it comes to individual assistance, when FEMA comes in, if you do hit those federal individual assistance thresholds, which are actually quite high, in Vermont, until we just don't typically have a lot of individual assistance disasters until the last couple of years. That's where you hit a threshold where a certain number of homes and private properties are damaged. The FEMA, the federal model and the state model is really to rely on volunteers and philanthropy to get people back onto their feet over the long term. If you do hit that FEMA individual assistance threshold, it's really funding to get people like temporarily housed, get them clothed, get them fed, and kind of get them stabilized, but it doesn't really support long-term recovery. So nationwide, you have to stand up long-term recovery groups. Vermont has had to kind of reinvent this when it happens. In my experience, having lived in the South, I was in Mississippi before this, but also lived in Louisiana, Virginia, New York, Maryland. Other regions are more frequently disastered and have a bit more robust recovery framework. In Vermont and New England, I think we're still learning how to do this. So that's my presentation. We're also a climate haven, like Western North Carolina. And, the thing is, relatively speaking, we are. The problem is where our settlement patterns are. And it's really challenging, again, I'll get this governance issue, when you're making planning decisions at that hyper municipal level, it makes it really challenging to figure out how do you grow up and away from flood hazards. And how do you fund that, especially in the absence of federal funding? That's it.
Right. Thank you, Chris. So now we will open it up to questions for all of the panelists. And so as a reminder, we welcome you to use the Slido. I think we'll put the direction or just both. I think for those of you online, it's been reminded in the chat a few times, but I'll just mention it, right? It's just hashtag Basque 2025 once you go to Slido. But I'm going to actually take the prerogative to ask a quick question or a question, and then I'll go to some of the Slido questions. But one of the questions I have is maybe goes back to the first few talks, and so it's really but a question for everyone, which we heard from Kathy that the Hurricane Helene and its rainfall impacts was pretty well forecasted, particularly the day before, in terms of the potential impact in the region. But part of that we heard, of course, from both of the START talks was due to the fact that there was this precursor rain event, which had already dumped a large amount of rainfall in the region. And so this comes to like more of a communication aspect of, you know, how well are we when the forecasts are good, how well is the impact of, it's not just the event, it's the fact that it's been raining for 2 to 3 days before, which is really made, so even if we get another 15 inches of rain, which is a lot, it's already on top of 10 inches of rain that's happened over the last few days, which of course impacts soil moisture and all of that. And so I'm just curious of, during Helene, was this a discussion, right, in the broader context of the fact that it had already been raining quite a bit? And I don't know, maybe Kathy, since you're in the room, I'll give you the first option, and then Ken, if you have any thoughts or anybody else has any thoughts.
It had been part of the conversation, but it all got grouped together. It all kind of became Helene, or all became this hurricane, or all, you know, the way people were talking about it. So people still don't parse them out as separate events. But yeah, I mean, I remember emailing someone in Asheville and they'd already received 6 inches of rain on Thursday morning, which is a big event for that area already. But no, I would say the communication was lacking there.
Ken, do you have anything to add, or anyone else?
I mean, it probably just add that the impacts of this event, probably a lot of it was forecastable, and there was good communication in some respects. But some of the things that happened, no one really expected. And the example I would give, because I never expected to be without potable water for almost 2 months. And I think that's, I don't think anyone was actually expecting the Asheville water system to get wiped out. There's sort of a backstory to that it was actually damaged in the 2004 flood event that Kathy alluded to. So they built some backup distribution pipes, buried them 25 feet deep, thinking that was enough, and it wasn't. Those pipes got washed away, as well as the main distribution pipes. And that was one of the issues, that the distribution system was cut off for 3 weeks, basically, before they could rebuild that. So I think it came up in our pre-conference or pre-workshop discussion, maybe a little bit of failure of imagination, what could really happen in this event. And I think we've kind of failed there to imagine the kinds of impacts that were actually possible.
Can I add something briefly to that?
Yeah, go ahead, Chris.
So, I was watching what was coming into Western North Carolina. And of course, you guys had the winds in addition to the rains. What happened there could absolutely happen here. But we, even during Irene, we dodged it. During Sandy, we dodged it, the worst of the winds. We have severe windstorms in absence of flooding too. But what I was trying to communicate to friends back home was, understand you've had a lot of rain. You're about to get a lot more rain. You're gonna have severe winds on top of this, and it's going to blow down trees. If you're leaving home, you got to leave home now. And people I grew up down there, but I mean, I think mountain people are generally the same everywhere. They are really reluctant to leave their homes. And so I keep thinking my nightmare here is like, let's say we have our antecedent, foot of rain, and then we got another 18 inches coming. Is the message in Vermont and New Hampshire going to be, if you live anywhere near a stream or river, you need to evacuate to high ground now because you're not going to be able to leave. And you're not just going to have inundation flooding. The hills are going to come down, the banks are going to collapse, your homes are going to wash away. But maybe that's the kind of messaging we need to say. And I have no idea where people are going to go. But I mean, in my very practical applied world where I've got responsibilities, to support municipalities and support in our 27 town region, our 26 emergency management directors. I mean, just how do we have effective communication about get the hell out now while you can?
Yeah. Thanks. So maybe I'm gonna ask a quick follow-up question related to this then, which is, and I think this actually was a theme that was discussed yesterday some during the workshop, which was related to the fact that communication maybe isn't the only thing that's important during these events, and that in this case, as we talked about, it was maybe well communicated, whether through the Weather Service or through kind of local agencies, but maybe there's an aspect of how do we, of course we can communicate in, okay, well you Chris, you were just touching on a couple things, right? You can communicate in different ways that shows the potential impacts, not just how much rain will fall, for example. But then we saw in Amir's presentation that, there are efforts to kind of model these type of events and the impacts it might have on infrastructure. And so is one of the missing links, I guess, doing this a little bit more broadly and not just relying on the fact of, okay, we know that X amount of rain, which will lead to X amount of flooding potentially, and actually try to model the actual impacts of these events in advance so we can give even more detailed information of the specific infrastructure that would be impacted. I know it's a kind of a broad, difficult question, but I don't know if anybody has an additional thought on that.
Can I talk about that?
Yes, please, Amir.
A few years ago, we published a paper specifically on this topic, impact-based prediction. And the argument is that we need to go beyond just monitoring events. And we have to link them to expected impacts. Of course, we'll be wrong all the time, but sometimes we'll get it more or less correct. And that is absolutely needed, whether it's drought or floods or fires. That expected impact is really important for decision making. If you know what is the expected impact, then you can make a decision appropriately. Without that, I mean, it's really hard to make a decision.
And I'll chime in. If you're a small business owner in maybe Marshall, North Carolina, and you aren't looking at the weather forecast all the time, being able to better make that leap for folks, whether it's through modeling, communication, that whole chain for businesses, schools, all the important places that people need to access, I think is really, really valuable and what we don't have right now.
And I guess maybe just to add to put now Ken's presentation in perspective, right? It was a little bit of, he mentioned at his own home, it was a 1,000-year event. And so there's also the fact that when we get these type of such extreme events, there is even our current systems and modeling approaches and just, historical understanding of what the impacts would be maybe are just limited by the fact that it's such an out of sample event that it is a little bit hard to communicate or to even realize what the impact might, or to even imagine what the impact will be. Which is, I think, also a discussion that we had yesterday as it relates to the LA wildfires was kind of a similar aspect there. So, okay, I'm going to move over to Slido, and I have the first question in Slido. And so for those that are participating online, I welcome you to fully use Slido by upvoting questions that you think are interesting. But I'll start with the first question, which actually comes from one of the board members, Bernadette here, which is for you, Chris, which is asking that we'd like to hear a little bit more about the status of the National Water Model, what all it will include, and when it may become available more broadly.
So I'm not a great, I'm using it as a practitioner, it's hard for me to really speak to where all it's going. I think they're using us. I think us in Missouri to kind of help inform how it can its utility. I can say I'll know more because I think we have a meeting about it either this. I think it's this afternoon. But I find it to be quite accessible and useful, especially in looking back. I haven't used it yet to kind of look at for its predictive capacities on what might happen with an event that's in the forecast. But I thought it was really helpful to go back because you can go down to days, weeks, months, and I can kind of, I've used it already to talk to emergency managers about like, here were our antecedent moisture conditions ahead of the 2023 event. So as an emergency manager, you need to really pay attention to like just when you need to start reading those detailed national, Weather Service office forecasts about what levels of confidence they have among the agreement in the models and agreement among models. So you can kind of look at what your antecedent conditions are. I mean, I'm not a specialist in this. I'm just talking about how I use it in our work. So I can't answer the broader question, but I do think it's going to be a useful tool, and I don't know what the cuts to NOAA, what the implications are for that, for its its continuation.
Thank you.
I personally struggle with something that's developed at the national scale when you're thinking about some of these smaller creeks in rural Western North Carolina that caused a lot of damage. So I think it's a both and kind of value addition. I don't know that it's going to solve all of our flooding problems.
And I'll just add to Kathy's point, what we're seeing here, like a number of buyouts and other things, where we are seeing a lot of just violent damage is on these blue line streams, these just unnamed drainages that are just exploding and carrying cobbles and debris, into and through and over homes. And that's our newest thing in warning towns. It's like, it's not just the bigger brooks and rivers. You have to watch everything now. Vermont has passed legislation where we're going to regulate development. The state's going to take it on, regulating development in all river corridors and larger brook corridors effective 2028. So I think that's a big policy lesson that we've learned, but the damage that we're seeing caused on these smaller drainages is just profound.
So I'm gonna maybe move to a slightly different topic, which it's maybe phrased right now, and it's from Effie, one of the board members, which is framed maybe more as a comment, but I'd like to maybe offer as an opportunity for those of you to maybe elaborate a little bit more, which is, and it's okay. I'll just read it exactly, which is Amir mentioned in your talk that the need to update IDF curves to account for non-stationarity. For events such as Helene, which are 1,000-year return periods, we really need to go beyond IDFs and start working on updated PMP estimates, right? So probable maximum precipitation. And so there was a recent report from the National Academies on PMP. And so I don't know, maybe if Amir or Ken want to provide some thoughts on the use of that.
I totally agree. I don't think we talk about PMP enough. Most of the methods we're using were developed back in the 80s, the WMO guideline, and we really have to go back and look at them and find alternative methods and maybe improve our understanding of probable maximum precipitation. I mean, for events like this, I totally agree. We don't really know if our estimates based on WMO are relevant today.
Yes.
Yeah, I think just to add to that, I think there's this area of or maybe category of extreme precipitation events that's from maybe kind of almost call it garden variety of extremes, the 100-year type of event, to PMP, but you have these other events that are on the tail. Helene, is it a PMP event? Well, might be close in some areas, but it's also the type of an event that I don't think we do a very good job of establishing its probability. And this comes up actually right now. I mean, people are trying to decide how to rebuild. The county and city are trying to decide here, what kind of new, maybe regulations they should have on rebuilding. And in some ways, I don't know what the real probability of an Helene type of event is. Atlas 14 says it's more, at least in a lot of places around here, more than 1,000-year event. But in a non-stationary climate, I don't know. I'm not so sure. Maybe it's a 200-year event or a 500-year event, and that will be changing into the future. So I think research to look into this area of very extreme events, maybe between the 100-year and a PMP event, and in the context of non-stationary is I think sorely needed. So kind of echo what Amir said already.
And I'll just say the data for Atlas 14 for North Carolina ends in 2000. So we're missing 25 years of data in there.
So maybe building on this question, another question from Slido is, and it's maybe for all of you, but is, curious to hear your thoughts about what lessons have been learned or for example, that are being incorporated into the rebuilding process. So particularly, as Western North Carolina is kind of building back the kind of water infrastructure and mobile service availability, new building codes, county plans. Are these discussions, or do you have thoughts on this? Are you involved in any of these type of discussions? And maybe I'll just also towards the end, it'd be nice to maybe hear a little bit from Chris's perspective of being involved in some of these processes in Vermont.
I'll just say that number one, I'm not involved in those discussions, but there have been some responses to Helene, and as to give you an example, the Asheville policies about building in the floodplain have been modified to be kind of in direct, what should I say, agreement with what FEMA demands. So there isn't any gap between what they had and what FEMA demands for flood insurance, for example. The larger question of how should we change our policies about rebuilding in some more fundamental way, I think the points have been raised, or the issue has been raised, but I'm not sure they really know what to do, how to do that at this point in time. When we do not have official estimates for the future, if under a non-stationary climate, the fact we don't have anything out there, I think, is a barrier for a lot of government agencies.
So we scaled IDF curves for Department of Transportation, and they were using some of those in the rebuild. So that's one piece, and it took me going through this disaster with the state to truly understand there are immediate short-term recovery needs that are still happening. And recovery and resiliency shouldn't be at odds with each other and should be well integrated, but they just aren't yet. North Carolina is excellent at an immediate response and recovery. Am I in conversations about long-term resiliency and planning? Yes, but those almost seem like we need to get people in houses, we need to get kids back in their schools. Those things are the immediate needs. And then longer term, how do we reimagine cities? And I think yesterday we heard about Paradise, California, that they're totally, wholly resilient and integrated. So I know I'm saying it, and I know some of you are saying, well, you can't do this without thinking about resilience, but sometimes the immediate is just going to win out.
I'll just add to that. The immediate need to rebuild is overwhelming and continues to be here. And we do not have kind of certainly in place a plan for, more resiliency. And people, like, as Kathy said, we need to get these roads rebuilt and homes rebuilt and everything rebuilt so people can get back to living a normal life.
I can add that, so after Irene, Vermont changed its road codes and standards. It changed, Vermont, we're really fortunate to have a number of river engineers throughout the state that advise road crews, state homeowners. And one of the things we learned was in doing the repairs, don't make the situation worse for these more frequent events that are coming. So we saw a lot of like further encroachment into not only the floodplains, but also the channels when we were rebuilding roads in places. So how do you do that smarter? Establishing higher standards for culverts and bridges for when they are rebuilt. So I think we've learned a lot and have done a lot on the policy perspective. Municipalities, and we've seen there was actually, you can measure the difference in places where mitigation measures were put in place after Irene that made a huge difference for the 2023 and 2024 flooding. One of the challenges we have is, again, hazard mitigation planning at this hyper local municipality by municipality level. Our flood hazard bylaws are administered on a town by town by town level. And most of our floodplain administrators just don't have the experience really to know what they're doing. And I'm not knocking them, they would say the same thing. So we have a lot of, I think, fundamental governance issues as a result of the flooding. I'm seeing a number of our towns, and I've said this publicly, I don't mind saying it here, I'm seeing them break. And increasingly in Vermont now, we're starting to have, it's actually spurred a revisiting of our governance structure, starting to talk about, well, should we have county or regional governance? Should we look at councils of government? Because I'm talking to the academies, one of the things, my dream study is actually looking at governance structure, governance capacity, and climate adaptation and resilience. Because I think New England in particular has huge exposure, but I know that it's not a walk in the park for where you have county government and other states too. But I think it's a fundamental question we're going to have to ask, especially if we're moving towards a preparedness, mitigation, response and recovery framework where it's moving more towards local and state self-reliance.
Can I share one example from California? So this is not Helene specific, but a few years ago, after several extreme events, California Department of Transportation asked us to update California IDF curves using our non-stationary model. So we recently delivered the updated IDF curves. It's in an independent review process now. And the plan is that in future, they want all infrastructure design to be based on this updated IDF curves as a kind of adaptation strategy in response to extreme precipitation events.
So I have a question that it's kind of on a different topic, but I'll ask it because it's coming from one of the board members, Neil, and it's also something that kind of relates to the discussions we were having yesterday too, when we were particularly learning some about recent wildfires, which is, well, Neil frames it as dumb question on compound fire and precipitation. Almost by definition, the year before a remarkably dry year will be a wet year. Is the evidence for this whiplash, and I think, Amir, you mentioned this in your presentation, more substantial than that kind of simple definition that Neil provides?
There are a couple of papers already that show the whiplash events have increased in the past decades. So regardless of this issue of fires, we're seeing more and more of rapid transitions from wet to dry, dry to wet. Kathy also mentioned that. So again, empirically, we can see that in our observations. When it comes to fires, specifically years where you see significant change in fuel loading. Fuel loading is what matters. And when you look at those wet years, it's wet years followed by a dry year because you need also drying of fuels. So that combination is definitely needed. So yes, I agree that in general, when you have a wet year, the one before or after is probably the opposite signal. But my point was that right now, if you look at our current approach to extreme events. We have drought monitoring by one agency, flood monitoring done separately. I think we need to move toward kind of integrated system where we look at droughts, floods, fires, landslides all together as series of events that can interact with each other. So ideally, we need to design our monitoring systems, prediction systems all in an integrated way.
Thank you. I got another question that's coming, and I'm just following as things are moving up the list as people upvote them. Is a question from Brad, the chair of the board, which is related, I think, to the kind of impact of terrain on these type of events. So for Helene, steep and complex terrain turned heavy rain into a destructive dynamic force with a higher loss of life than a Florida flooding event that is more about inundation and passive losses. And so how do we account for these complex terrain in general? And so I think that could relate to the type of modeling, for example, Amir, that you've been doing in terms of planning, Chris, or even just in how we look at flooding and the impact of rainfall on it more broadly. So anybody want to start to tackle that question? So yeah,
Terrain
stuff.
definitely matters. So it's a huge factor. It's definitely the difference between extreme and or basically just extreme event and human disaster is sometimes that terrain and difference in elevation. In the way that we process IDF curves, no, we don't account for terrain. It's based on data, whatever historical data gives you. That's it. Basically, all the processes are based on historical time series. So at least not in what I presented, not yet.
From the monitoring perspective, we are under monitored in Western North Carolina. And I mean, we could do all sorts of transects and hill slopes that we just don't have and we don't understand. So that's what I'd advocate for.
The more, especially I would say, animated things that we can use at a local level, like with road foremen and emergency management directors, things where we can animate how water moves through the landscape under different scenarios would be incredibly helpful. This is a little different tool, but in my perfect world, we would have stream tables in every region of the state, and we would have them out at the towns on a regular basis. We would have them in schools to kind of teach these processes. They're incredibly useful. We actually have one with our conservation district, and it gets used pretty heavily, but could be used even more. But one thing I'll note is that because of the frequency of our disasters now, I think there is more appreciation for keeping woodlands as woodlands and meadows as meadows and wetlands as wetlands. We're seeing more and more interest now in permanent conservation of floodplains. I don't know to what extent at the local level this is going to translate to changes in zoning bylaw to preclude more impervious surface up in the headwaters. But I think we're starting to see more and more of a recognition that it's not going to stop these massive events, but it's going to be critical to a buffer. And the reason I bring that up, I know that's not modeling related, but even in the absence of models, I think just the frequency of events is getting people to understand, hey, we're just going to have to bite the bullet and maybe say, I love one of my favorite quotes is from Wendell Berry, do unto those downstream as you'd have those upstream do unto you. I think we're starting to see, even in the absence of the modeling, a greater recognition of the role of vegetation, soils, and other things to try to keep people safe downstream.
Yeah, so I keep doing that. Sorry. Bad habit of unmuting actually on the thing. I guess so. Maybe just to pull up on that or kind of wrap that up is that when we think about the flooding impacts, right, from extreme rainfall or from compound events more broadly, that even though our improvement in our weather forecast continues to be enhanced, right? And we're able to kind of, we saw in the example of Hurricane Helene predict the amount of rainfall and that it would have really large and widespread impacts. That when you start to get to understanding and being able to predict those impacts from a flooding perspective, that even the highest resolution models that we have on a weather scale, that you really get down to hyper local and really where the most, wherever the patch of the highest rainfall is, will have a huge impact on the rainfall in a valley, which could be different, I think, in areas with less terrain, where of course it is flatter, and therefore the impacts of the rainfall are a little bit different. And so it's a very local issue. I'm gonna move on to a question that's coming from one of the attendees, which is, first, thank you for your great presentations. What do you think the impacts to communities, especially people in communities that might be dealing with that were impacted by Helene and other hurricanes, with the National Weather Service and NOAA at its current reduced capacity with less data? So I think, to phrase it slightly differently, is, does anybody want to comment on, what are the potential impacts of having the less data? We've heard already from Kathy that more data is needed. And so what would be the implications of if we have less data on forecasting or understanding the impacts of these events, both after, but also when we retrospectively look at them, I think, and try to assess what's happened?
I will say the National Weather Service is a national treasure. They prevented extreme loss of life in Helene. We did lose a lot of lives, but it could have been much worse. And we need people in the National Weather Service. The people are what matters. AI wouldn't have written the statement that came out on that Thursday saying this will be the most catastrophic event of modern times. So that's my comment about what we need in the National Weather Service. And with data, yeah, we need the data to keep coming. We love numbers. I mean, we all have our wearables and whatnot. We need to invest in that as much as possible. And wherever that's coming from, if that's NOAA or if that's a state agency like mine that has a mesonet, we just need it all.
Yeah, Ken, did you want to?
Yeah, I mean, I would just say a couple things. Number one, the potential impacts of cuts. I mean, where will it hit? One of the things that I worry about is loss of the long-term monitoring networks that we have and the data that comes in. I mean, how are we going to provide a perspective on this event versus 1916, get a true risk or true analysis of the probability of these events if we don't have maintenance of the long-term monitoring networks? We have long data sets, and those are maintained over time. So that would be one point. And the second point actually may go back to the discussion we just had, would be there was some places that had massive loss of life and damage in these hollers up here, the creeks that ran through. And could we have predicted in some of those cases the water levels that did occur that caused these? If we had modeling that went down to the scale that's needed, we could model some of these maybe maybe they're not gauged right now, some of these creeks, like the one that's outside my subdivision, but could we do a better job of forecasting whether or not we're going to have a debris flow that, in one case, wiped out 11 members of the same family, extended family, or the person who lost their life a quarter of a mile upstream from where I live? And so I think that this event, particularly in the kind of terrain we have here, points to the need for even better modeling and more fine-scale modeling.
Oh, I'm going to switch topics slightly, which is one of, and this question is coming from Jonathan, one of the board members, and it's framed for Chris, but I think maybe welcome any, thoughts from all of you, which is, for risk assessment of households flooded, how much coordination takes place with the local public agencies? Public health agencies. Probably the largest health risk comes from cleaning basements covered in mold, and, ER asthma visits that spike after these events.
Gosh. So we're such a small state. Most of the direction comes from the state's Department of Health, and then it gets filtered down to the volunteer groups that stand up to try to help people with mucking out. I'll just underscore, in addition to other funding cuts, public radio is so important. Getting word out across the broadest popular cross section of the state, because in such a small rural state without much kind of mainstream media, in other words, we don't have television channels that cover the whole state. They really cover, Burlington, some of the other population centers. We're so reliant on our Vermont Department of Health getting word out. We do have some local public health officers. We do have some district Department of Health folk, but really we rely on networks that get word out through these volunteer networks. I don't know if I'm answering your question well, but it's really reliant on just harnessing the social networks we already have. One thing I'll note, though, in the state is the Agency of Human Services is responsible for, so Vermont Emergency Management handles all the public infrastructure type disaster recovery and assisting towns with that. Throughout all of state government, it's the Agency of Human Services that's supposed to help people with households and individuals with long-term recovery. We have one staff person that covers that. I don't know what this looks like in other states, but this individual and household recovery piece, I don't think it's just Vermont. I'm really worried about what the future holds, not only for like the initial recovery and like getting people mucked out, getting the drywall cut out, drying homes, but it's what the long-term recovery looks like. I've been trying to get data in Vermont. I'm not knocking anybody on how many people are still displaced, how many people are underhoused, how many people are living in substandard housing. And we don't have those numbers because we don't have the capacity to gather that information. And I don't know what the situation is in North Carolina and Tennessee, Kentucky, California, elsewhere, but even just not knowing how many people are still at risk is a big issue to me. I wasn't down in the Gulf Coast for Katrina, but that's where kind of my awake, I lived in Mississippi and Louisiana. I saw the response there, a lack of response, and it kind of made me think wherever I'm at, I don't want that to happen on my watch. But now I'm living it here, and it's like I don't know how to fix this. As far as like getting people healthy and back on their feet as quickly as possible, and it's just getting worse. And I don't know if it's getting any better in any states with more experience with this or not, but I'm really, really worried about it, both in terms of physical health and mental health.
So I'm going to actually ask a follow-up question, which is a question that's come from one of the attendees, which is relates a little bit back to your presentation, Chris, which is just, but it's really, again, for any of the panelists, do you anticipate increased loss of life and damages from disasters as states and localities are relied on more for recovery and planning, particularly those states that are that may be less inclined to address climate change?
I'd like others to weigh in on this. I do think we're going to see more deaths from flooding, but actually our biggest killer is heat. More people die due to our extreme heat events than they are from flooding, and that flies way under the radar. But we haven't lost a lot of lives here. I mean, any loss of life is awful, but relative to like the numbers we saw in North Carolina, we haven't seen that yet. But we also didn't see that scale of event yet. So I'd love for others to weigh in on this one.
Anyone else have any thoughts? Yeah, Ken?
It seems like one shouldn't have to say this, but I will say it, that, I mean, if we ignore the risks to global warming and increased atmospheric water vapor in the atmosphere, we're simply allowing our systems, our society, and our infrastructure to become less and less resilient, because these events will become more intense in the future. And if we're talking about long-lived infrastructure, which, you know, we're talking about homes and roads and bridges and all that, those are meant to last for 50 to 100 years, and will simply be building from the very beginning less resilient infrastructure if we ignore this.
I agree with what Ken said, and I'm trying to parse out if there's this undercurrent of just North Carolina is reluctant to address climate change. And I want to push back on that, because these generalizations are sometimes unhelpful. And there are often communities that are trying, or don't have the staff that they need, or don't have resources, but really do know that climate change is a problem. Maybe they're not shouting it the way that some communities do, but we see loss of life in well-resourced communities too. So we're just not doing a great job anywhere. I mean, that's the bottom line.
I serve on the state climate council. We are, you know, Vermont has been kind of on the leading edge of a lot of this stuff. The challenge that I'm finding is, you know, with our frequency of disasters, I'm kind of taking the lead in drafting and updating our climate action plan. I'm the rural resilience and adaptation guy, and I'm drafting the chapter on the built environment. What I'm seeing is so much of our conversation and so much of the cost that we're talking about is around greenhouse gas reduction, which is absolutely critical. I've been working on this stuff since the late 80s. So I am not a skeptic in the least, but I look at Vermont and I almost feel like we're an island state. What resources do we put towards greenhouse gas reduction versus adaptation resilience coupled with rebuilding and recovery? If you have a fixed amount of resources, the amount of greenhouse gases that we produce is incredibly small. This isn't an either or proposition, but if we have money, and especially under a period of scarcity, where do we prioritize putting that funding? And this is a question I keep trying to ask, because my concern is that we need, to the extent that we're talking like actual like a cash flow issue, you know, my response is right now, as far as Vermont's contribution to overall global warming, let's keep doing the good stuff we've been doing on energy efficiency, renewables, and other work. But we've got to really double down on the resilience and adaptation work, even as we're trying to help people recover. But I don't know, you know, and this is a really sensitive topic to me, because, you know, we've had these robust policy conversations, but honestly, the resilience and adaptation piece keeps kind of falling off the table. And we keep going back to kind of being hyper-focused on the greenhouse gas reduction. And I guess not either or, but in my world, I'm dealing with real dollars, real investment, real people. And I don't know the answer, but I think we have to deal with it at a national and global scale. Doing it at just the local and state level makes no damn sense. Pardon my French.
So a question from an attendee for Amir. So it says, thank you, Amir, for a great presentation. Most of your analysis in your presentation showed that flood risk are increasing. However, long-term USGS observations show the opposite trend. How do you reconcile those or convey it to a planner, for example?
Great question. Let me highlight two issues here. So let's look at dollar value, to the dollar value of impacts. That is going up significantly. And yes, dollar value is not just extreme events, it includes exposure. Our exposure has increased significantly, and that's what matters when it comes to these events. At the end of the day, we want to look at impacts that is increasing. Now, when you look at USGS observations and there's flood risk, First of all, in most basins, we have managed systems. You have dams and reservoirs. If you look at your typical 20-year flood, 50-year flood, and a lot of these common events, yes, there is that downward trend. That's exactly right. But those are not our main impactful events. Events that matter at the end of the day are Helene type or Katrina type events. And they are not the typical events that we see in USGS observations, and they are beyond our management capacity. Those are increasing.
Thank you. So another question on a different topic, and so it open to anybody, and is related to. So reading the question, Hurricane Helene caused large forest blowdowns that raise concerns about the risk of wildlife, loss of wildlife habitat, reduced water quality, and spread of invasive species. Does anybody want to talk about forest cleanup efforts? And so it was, I think the question, was framed around Hurricane Helene, but I welcome thoughts from Chris or anybody else on other examples of similar events. Yeah, Ken.
I was just going to say the recent wildfires we had here. I'm no expert on this at all, but one of the things they encountered, not only all the downed trees are fuel for fire, but firefighting efforts were severely hampered by all the downed trees. They couldn't get equipment into places, and so it became very difficult. It was a very challenging situation. And actually, somebody in the local newspaper asked, wanted a question answered. When are they going to clean up the forests? Well, you're talking, I don't know, 700,000 acres of forest land that was heavily damaged. They can't be cleaned up. There's the resources aren't there to do anything like that. So we're actually going to be living with this for quite a while now. Every time a wildfire breaks out in one of these areas that were heavily damaged, the firefighters are going to encounter all these downed trees that not only are fuel but hamper firefighting operations.
I'll just add, before I came here to Vermont, I was on the landscape architecture faculty at Mississippi State, and we did a lot of work around it's called a program called Firewise. USDA supports it. It's Firewise at both the household scale and community scale. And I don't feel like I've not really seen much Firewise material in the Northeast. I don't know about, back home in Virginia, but I'm just not, there's just not a lot of wildfire community scale planning here. I mean, there's certainly like the fire department's trained on it, but as far as like taking wildfire more into account, both, before blowdowns or after, what does that look like? Part of what drove us in the Southeast, of course, to develop those materials was after the hurricane with all the tree falls, and you're always the wildfire risk elevates. And Amir may have a lot more, information on what's effective as far as community outreach and engagement around like post blowdown or post wind event, post fuel loading. How do you manage that? But I really do worry about the Mountain East not taking wildland fire as much into account as it should. One thing I'll put into the chat too, in Vermont, we're doing a lot of work around large forest block continuity and habitat connectors. I'll load in a link to the what's called the Staying Connected Initiative, which looks at larger scale, because wildlife was mentioned, maintaining and improving large scale habitat blocks and the connectors, in case anybody's interested. I'll put that in the chat.
So we'll have, I think we have time for maybe about a few more questions. So another question that's from the Slido, which I think is a broader question, but Chris, you might have some thoughts on it, as I think it's originally framed for you, which is, as a local emergency manager in Northeast Massachusetts, we also face very similar governance challenges as well as funding challenges without grants. are there currently any efforts to regionalize preparedness, recovery, et cetera?
Oh, I wish. You know how we are in New England, we are so hyper local. I think that's where we're going to have to, especially if the federal government withdraws, if the federal model changes. I think, I mean, and honestly, even if it doesn't, I think we're going to need to look at more of like a regional compact to better support each other. There are already mutual aid agreements in place, but rural New England and rural Northeast, I would include, you know, New York, Pennsylvania, New Jersey, elsewhere in this too. I think we really got to kind of figure out how to make this work for us, because ultimately, you know, I chair this group called Connect River Watershed Partnership, and one of the things that I always present is the sediment plume going into Long Island Sound in the wake of Irene, and ultimately, urban and rural Northeast have a lot of stake in one another's well-being, and I think we really need to have these kinds of conversations. So I'm glad you brought it up. I'm not aware of anything in the offing right now. And I think part of it is probably going to wind up. I would love for it to be independent of any federal changes to federal policy, but I think changes to federal policy may actually necessitate it.
So another question actually goes back to communication. So this is really for anyone that wants to provide a perspective, which is how to communicate impacts without creating panic in the public. And so I know we talked a little bit about the effective communication in some ways from the National Weather Service in the advance of Helene, but in some cases, when you are talking about these events that are outside maybe what you've experienced or you haven't experienced in 100 years, I think a good example was the for Helene, right? It referenced 1916. So I'm not very few people in the region were alive in 1916 to kind of relate back to that. And so does anybody have thoughts on how communication can impact not only panic, but how do you do so in effective ways?
I like to think of it as I would rather be overprepared and underwhelmed than underprepared and overwhelmed. And that doesn't necessarily get to the panic, but I think sometimes we're just so afraid to prepare for the worst or just can't imagine the worst that we don't. But I do think about this with those weather service forecasts because we are seeing more and more of these narrative forecasts that are making pleas to people or starting to veer off the kind of standard weather service script. And I thought to myself, actually, on the way over here today, at what point does that sort of plea become less effective because it's showing up everywhere, or is it showing up everywhere because these are happening more often? But I mean, I think it also gets back to some of the visualizations that people need. What does that actually look like on the ground? What does that amount of water coming down one of these hollers and these small creeks look like for your small business? I think we're counting on text and voice warnings, but we are visual learners. And the man I was sitting next to yesterday from the fire panel was saying they were going to start showing how the garbage cans can catch on fire and then catch the whole house on fire because people need to see it and not just hear it. So
I'm gonna ask a question myself, which is last year during the Basque as a spring meeting, we actually had an open session similar to this, but it was focused on the role of artificial intelligence and machine learning in kind of the weather and climate enterprise. And so I'm curious if any of you use AI or machine learning in any of the approaches and methodologies for your work, or if you have thoughts on what role AI and machine learning could play in maybe advancing forecasts of such extreme events that are out of sample or at space and time scales that could be relevant for response and recovery and resilience operations.
We're not, but to the extent that we could do animations again in these stream valleys for town, like going back to what Kathy was just talking about. you know, in addition to videos and pictures of what happened in the past, if there's a way that we can use that to model quickly and give accessibility to that to like municipal county planners who are working directly with the public. If people can develop tool sets, or maybe they exist out there, that would be awesome.
We use AI for different types of applications. One of the recent ones, we're exploring backward risk assessment, where we start from impacts and then we use AI to find drivers of those events. And the idea is, especially this is important for events that are statistically independent, but they interact with each other, they lead to some kind of impacts. In those kind of methods, current statistical methods for independent events, again, we consider them independent, we just multiply probabilities. But there are processes that link sometimes those independent events, like rain over burned areas and so forth. And that's where I think AI can help a lot. Our center here also generates near real-time extreme precipitation data based on AI approach that's publicly available. There are many applications. There's certainly opportunities to use advanced AIs for the applications related to extreme events.
Okay, so I think we have just a few minutes left. So what I'd like to do is just do a final wrap up and allow each of the panelists, and I'll start in the order of the presentations, to provide any kind of concluding remarks, and mostly what within the kind of framework of thinking in your area of work, right? Whether that be compound flooding, extreme precipitation analysis, kind of regional planning, you know, within these events that we've been talking about, either Helene or another one in your area, you know, is there a lesson or that you've learned in your own scholarship and research and analysis that you think is worth sharing as either relates to, you know, improving forecast, improving impacts, translation, anything like that, or so a lesson that you've learned, or an area, a gap that you still see as something that is important that the research community continue to think about. And I know this has come up a little bit in our discussion, so I welcome kind of a concluding remark on that. So Ken, do you mind starting?
Maybe I should just reiterate a point I made earlier, and that is that as I watch the local governments, government agencies, you know, kind of struggling with what do we do about future rebuilding and not being in a way prepared to have the information needed to make quick decisions about the future of, you know, future risks and probability of these events that, you know, I know I've talked about it for decades now, but we need to have some sort of national resources that states themselves aren't, you know, reliant on doing their own thing, like North Carolina or Vermont or whatever, or California, that we have national resources that can be sources for that kind of information when you're in the middle of dealing with the urgency of rebuilding versus long-term planning.
Kathy?
Yeah, so the role of people in all of this cannot be stressed enough. And I'm thinking about the Monday after Helene, and I said we put that rapid reaction out. It got picked up by all the big news outlets, but I could tell my team felt like they weren't doing enough. Like we weren't up there with chainsaws and digging people out. And I want to stress to people that recovery takes all these types of people and your specific skills and strengths, and do what you're good at doing and help there. And the second piece is that a lot of donation centers just got absolutely overwhelmed with donations that were incredibly well-intentioned, but it then required them to pull people off recovery efforts, to sort through water bottles. At one point, they were just leaving them on rows on the street and just said, you know, whatever, somebody can come along and take them. Cash is always the best thing to give after a disaster. And again, it doesn't feel all that satisfying. You're not rounding up a drive, but it is truly the best thing you can do. So I think about your own role in resilience and recovery, bring your gifts to the table, and also just know what communities need, and it's not your old clothes.
Thanks, Kathy. Amir?
I highlight two gaps really briefly. One is the need for impact-based prediction of extreme events. And secondly, I think we need to put resources into developing adaptive design concepts or risk assessment concepts for our infrastructure systems. Usually impacts happen after failure of levees or some of the critical infrastructure systems. And that's where we have gaps. Our current design guidelines are primarily based on methods developed in the 70s and 80s. And that's where we need to revisit and update them.
Thanks. And last but not least, Chris.
Two things. One, I'll go back to the governance capacity issue. I think it's just maybe conversations and research is happening, but I'm just not aware of it on, what are examples of more resilient governance structures, capacity issues, especially in my area, specific area of interest. It's not exclusively rural, but I do think that's something we really need to get a handle on, and now is a good opportunity to learn based on the experience that's especially in the Mountain East, because that may look different than what's happening in the Midwest and West and other places. The other thing I'll add is really establishing networks of trust to try to mitigate the inevitable disinformation bullshit that follows in the wake of disasters and potentially has a risk of getting people killed or otherwise not getting the aid that they need. We need to keep building those layers of trust, those networks, so that when a disaster happens, there's a reliable source for information at the local level, county level, regional level, state level about what's really happening, and just being really candid about what is happening, what can happen, what will happen, to try to beat back the information that ultimately jeopardizes the local and state and federal recovery efforts.
Great. Well, I'd like to thank all of the panelists for your time, your preparation for the panel, and all of the answering all of the questions from the board and the attendees. So thank you. And now I'd like to turn it over to Brad Coleman, who will moderate our next session, which is focused on a wrap up and lessons learned from the discussions, not just from this morning, but also from our workshop yesterday. So Brad.
Thank you.
Thank you, Kevin. Another great event to discuss. I'm Brad Coleman, chair of the board. And first, we've been sitting all morning. Take a deep breath. If you want to stand up for just a second, kind of wiggle around a little bit, it might get us through this next hour and a half. If you're all set to go, that's good as well. We've been captivated over the last day learning about 3 extreme events: the LA fires, Phoenix heat, and Helene floods in North Carolina. The severity and impacts of these events were incredible. There was alarming destruction and loss of life. It is difficult to envision what those who were in the fires or the floods experienced. It's equally challenging to understand the tragedy and insidious impacts of heat that we learned about yesterday. As Kathy said earlier today, we can't forget these events. Here, over this last day, we've had the great fortune of hearing from many exceptional scientists, practitioners, and survivors. We've seen the impacts. We know that extreme events are increasingly frequent and more intense. We now need to bring it home. This is a call to action. Not only can we not forget, but we must look forward to the future and what can be done to mitigate against these events. Where are the critical gaps? Where were the wins? What were the lessons learned? These are often lessons that we don't want to repeat. Where in the pipeline will investments have the greatest impact and benefit? How do we move the ball down the field? We don't have the luxury of prioritizing all of it. Is it in the foundational sciences, the observations, the forecasting, the communication, and decision-making, or in modifications to infrastructure, codes, removing communication barriers or governance, among many others? This last session is designed to help us start answering these questions. We are fortunate to have 3 board members who have gathered information through the last day, their thoughts and your thoughts to help us in this closing discussion on next steps. Each will be given 10 minutes to share their thoughts. We will then have an hour for our final discussion. So without further ado, and we'll use Slido in this as well in the last discussion, I'm going to hand it over to our board member, Mingwei Yao, from faculty at San Jose State University.
Thank you, Brett. I just prepared this slide yesterday and today, so it's some thoughts put together. I don't think this is the one. Oh, this. All right, some summary of the case study for the Los Angeles fire. We talk about several fires in the case study, and I find that there's something like jumping around. Okay, so I find that there is some high similarity among several major fire that we mentioned, including the LA fire, Marshall campfire, etc. They have high heat, low humidity, very strong wind, and a buildup of fuel. Many speakers actually mentioned that the winds reached about 90 to 100 miles per hour, and there were usually 2 very wet years before with lots of precipitation building up fields, followed by a dry winter right before the fire. Just like the LA fire, there was no meaningful precipitation at all the winter before. So there were some already very well-known facts that we have a combined effect from short-term and long-term influences from weather and climate. This is what we know. There's a delay. I don't know. Click again. Click again. Is there another button I can click? Oh, okay. Just a little slow. There's a lot of knowns and unknowns, and I try to break this into 3 parts in the summary: before the fire, actual burn, and after fire. I want to identify some challenges, gaps, and needs. We can break into fundamental sciences, firefighting, communication, adaptation, and community resilience. Some of the things that we already know, this is building up what happened before the fire. This is the setting of these major fire. Many of the fire, like the top 20 fires in California, actually most happened after 2003, and the top 3 fires were after 2018. And the LA fire was kind of like a perfect storm. One of the speakers mentioned that it hits 99.95 percentile for the joint events of high temperature, low humidity, and high wind for this perfect condition. However, there are some unknown areas that I try to put together based on the speaker's talk. One is because there's increasing interfaces between wildland and urban areas called the WI. Not only the high elevation forest areas are now the regions of concern, but also low elevation arid regions start to see more fires. So this could mean that what will be the short-term and long-term condition of these locations in a changing environment? And could there be any shift of wind regimes under a potential changing atmospheric or hydrological condition? And for time-wise, there's also an expansion of fire season. More fires are seen in the late fall and winter, especially even in January, which was never seen before for LA region for this major fire. Even though we know some of the facts that we're going to have more fire, and this is going to happen more often, the actual trigger of ignition actually seem to vary between these fires. We've seen lightning, dry lightning, small fire that actually lead to a larger fire in the Marshall fire in Colorado, and human activity or power line. So these different triggering situation cause different challenges for the real firefighting event. The fire of 2020 summer is a remnant of a tropical storm. It just immediately ignited hundreds of wildfires altogether. And during the high winds of LA fire, the firefighting aircraft of CAL FIRE cannot be deployed. So this means that the weather condition actually can overwhelm the firefighters' capability to fight these fire? Should we have some specific attention for various type of events? And for before the fire, an actual burn, there is a unique keyword called the urban conflagration. And this is a combination of three factors: human, droughts, and winds. The structure themselves also provides the fuels, but not only vegetation around the houses. And the speaker from the insurance industry said that we have a parcel plus community, two components. Both need to be addressed, meaning that not only individual houses, but also the entire community have to be updated, because the embers will find the weakest link. And communities with less fire risk will also be impacted through conflagration by the nearby community with higher risks. So the goal is to reduce structural ignition and reduce the likelihood of conflagration. And the new communities seem to have a higher chance to be updated with a relatively small cost, $3,000, and become more fireproof. While remodeling of the existing home have more difficulties, not only from the uncertainty of the cost, but also more needs to address the behavioral, psychological sciences to help the homeowners to make the decision. Now, there are some other things we discussed just not in more detail. Some of these are from the Q&A session. One is like the land management. How do we build fire break areas? Do we use new resilient home, new built home to build these fire break zones? Do we have pavement versus new home next to canyon? Do we have green zone with irrigation or just bricks? This is also a question for urban planning. How do we build higher density residential area, but also have these new fire break implemented? Prescribed burns. This already has become a hot topic for the Cal Fire's operation. And can we identify regions to prioritize these prescribed burns, and what better time period should be implemented? What is the economic or health benefit cost analysis, incentive to have more prescribed burns and raise awareness by the community? Updating building codes, both from the home owner level and also from a state legislature level. Some Q&A question mentioned possible weather modification like cloud seeding. They also mentioned the reduction of greenhouse gases in general from a global perspective, and some quick discussion on the communication tool like alert system, social media, AI tools. So for the actual burn and after fire, there's more discussion on the health impact, such as air quality impact from particulate matter gases, water quality impact on the municipal water supplies, and possible compounding effects. Even though we didn't get to discuss that, I want to raise it here. How about compounding effect of gases, PM, smoke and heat? Indoor-outdoor exposure has been mentioned through the Marshall Fire case. And there's different influences, different level incidents. Some are with shorter impacts, but some are with long-term impact for different type of gas species or PM. So long-term epidemiology study on the cost for the public health, like ER visit or hospitalization rate, loss of school, work hours due to smoke, etc. How do these translate into economic cost? So with all this, I try to put together a summary on the key 3 points. The gaps in the foundational sciences, I try to identify from the speaker's note, expanding regions prone to fire, and we have an expanding wildfire season into winter. What does this mean to get more prepared, building more fire zones, etc.? But also, what does this mean for studying the meteorological condition of these regions that's changing under changing climate? So the fire dynamic season, civil engineering and urban planning sciences are also needed to study and guide the building of these fire break zones, optimize the chances of reducing these urban conflagration. And epidemiological studies on the short-term, long-term, indoor-outdoor impacts on smoke and gases on communities and vulnerable groups such as pregnant women or people with young child.
compounding effects of smoke and heat and water quality impacts. So there's a lot of things that probably will need to take a few years of study to follow up with the impacts. Shortfall in the translation of science into practice is the second bullet point. Again, these are just things I try to identify, and feel free to add to it. Cost benefit estimate of the adaptation decision making at different level. That means, do we have homeowner incentives to improve the building resilience? Do we provide incentive to home builders when they build new home in different state? And what about the prescribed burn? What's the communication to the society or the nearby neighbors about the benefits of that? Behavioral and psychological sciences communication to support these adaptation plans are also very important to translate the message to the public. Lastly, the opportunities to improve real-time responses. If there could be guidelines to reduce structural ignition and conflagration to the homeowner shortly before or during the red flag alert, people could get prepared to do things as they evacuate. And health guidelines on air and water quality during and after wildfire for different groups. Personally, because I live in North Cal, I don't see a lot of times these health guidelines be given out, even though there could be red flag days or we're impacted by smoke. Usually we just see a PM distribution, but what is the exact instruction for people with different level of sensitivity to take action themselves and reduce the health impact? So that's all. Thank you.
Okay, thank you very much, Peng Wei. That was an excellent summary. Why don't we move on now to the Phoenix Heat? We're gonna have Kevin Gurney from Arizona.
All right. So first, thank all the speakers for an excellent set of presentations yesterday on Phoenix extreme heat. Sorry, I'll let you move to the next slide. Thank you. So first, just starting with some emerging gaps in foundational science. There's some things that were pretty specific to the Southwest. I think the most important one of those might have been better modeling and better seasonal forecasts of monsoons. I was struck by the fact that these strings of hot days were dramatically interrupted by monsoonal rainfall. Very difficult thing to forecast, but very important seasonally to heat in the Southwest. The monsoon flow is very small, so it challenges a lot of the forecast models in terms of its scale. But an important piece of science that I think remains to be done. Then there's a lot of things that clearly were not just specific to the Southwest, but to all places that experience extreme heat, especially in urban environments. More and better environmental thermal data, obviously at fine scales, higher granularity. That's important to inputs to models. There's still lots of limit in better information, and more broadly, as I think David Saylor mentioned, total thermal environmental data, not just temperature, but other things like shades, building heights, wind regimes, surface characteristics, surface materials. All of these other aspects of the total thermal environment are just as important as temperature. I think there were a few what I would call sort of macroeconomic questions that came up that were still kind of unclear. The economic impacts of migration, going in and out of places like Phoenix, where they both have high tourism, but also these extreme heat events, people coming in and going out, what that means to the sort of economic viability of the region. Obviously, that affects tourism. It's not true everywhere, true in the Southwest. And then broader questions of things like infrastructural maintenance, not to dismiss the importance of health and deaths, but also the fact that these extreme events also put a lot of pressure on infrastructure, and there's still lots of open questions about what that means, how much does that cost, and the cost benefits of doing something about it. Also came up was this idea that There's a desire to do more digital twin style modeling and some of the data needs for that. That, of course, puts a lot of pressure on things like very high resolution commercial satellite imagery that's needed to support digital twin style modeling, which is really more adept at both modeling these extreme events and then the socioeconomic and human impacts of that on the ground. Interesting questions about feedbacks. There's still lots of questions on feedbacks. I put one example here that came up really quickly, this idea that extreme heat then puts pressure on air conditioning demand, which increases the discharge of local heat, which thereby increases air conditioning demand, so on and so forth. So some challenges very locally on feedbacks between both human behavior infrastructure and then the local thermal environment. Next slide. There was also clearly still some research needs around medical research, and in particular on particularly vulnerable communities. So we're thinking about the unhoused, immunocompromised individuals, et cetera. And then I think really importantly was what of the Phoenix experience and research that's gone on so far is translatable globally. What's common, what's idiosyncratic to Phoenix. And I found this chart on the right that just a projection in a 1.5 degree world, which we're almost at, how many days per year across different regions of the world and cities, how many days per year exceed 95 degrees. The same plot for 3 degrees is about an additional month in all of these. And as you can see, there's also some correlation with low and middle income countries here as well. So obviously this experience in Phoenix, where there's been a lot of research and a lot of effort, how much of that is translatable globally? What variation is there to social norms, to lifestyles, to communication networks that vary wildly across the planet, varying infrastructure, varying socioeconomics, et cetera? What lessons can be extrapolated and which cannot? I just put some examples here of the notorious heat wave in Paris in 2003. We were talking about hundreds of deaths per year. In Paris in 2003, there were nearly 15,000 heat-related deaths. That same year, in that summer, nearly 50,000 Europe-wide. And then in 2022 in London, I happened to be in London that summer, 664 deaths in London and nearly 3,000 UK-wide. So clearly a broad-based phenomenon that we need to take lessons learned and see how well they can be extrapolated. Next slide. Shortfalls in translation from science to practice. A few things seem to come up. Targeting impacted populations with specific messaging is clearly still very, very important. This idea that in the Phoenix case, there's lots of visitors that come to Phoenix from other places that are not used to extreme heat. And so how do you target those people to get messages out on how to manage extreme heat? The idea of messaging at airports and hotels. And then I thought that really great example of the unhoused population was quite impacted by things like just simple pocketed brochures. And so better understanding what messages work, where, when, and how, I think seems to be still an important need and opportunity to reach people better. I was surprised that there is no sort of national heat coordination in the US, and whether or not that ranks through disaster relief funding seems to be an important topic as we enter a time in which this will come up more and more. Uniformity in heat safety and response. The example of schools was brought up, but it's certainly equally applicable to outdoor workers, which may even be more critical internationally, where there are lots of places where populations spend a lot more time outdoors, either commuting by foot or by bicycle, for example, as opposed to in a car. But there still seems to be challenges in creating uniformity in both the messaging and the sort of gradations of what you do at certain heat levels. Education and training and standardization on recording heat-related fatalities came up again and again, that just the basic statistics on fatalities related to heat is still not uniformly tackled. There's still education that needs to be done such that we have a better understanding of the statistics around heat-related fatalities. Examples of challenges in just basic communication of extreme heat and the solutions being proposed. Dave Saylor brought up this idea of cool pavement that was very misinterpreted in the media. And so he mentioned that some of these are nuanced and just require better messaging, better follow-up on messaging so that there isn't misunderstandings about extreme heat and the solutions being proposed. And then, you know, it's not just about maximum temperature, that there are a lot more things associated with the sort of thermal environment other than just temperature that are critical to communicate and message to people. I mean, in the Phoenix example, of course, just extremely low humidity and dryness and solar exposure are all equally important to the sort of your experience in the thermal environment. And again, how to effectively propagate the successes in Phoenix to other places. Next slide. So opportunities to improve real-time response. I was impressed by the idea that it isn't just the response at the acute moment, but building preparation and systems that are sort of in place. I mean, classic emergency response preparation, you know, is equally important in heat as it is in other things. The power of institutional coordination. I mean, Phoenix has a heat office with the staff. That's lucky, but clearly something that has made a big difference. Dave Hondiolo talked about this a lot, made a huge difference there. And also, again, is an example of an opportunity that might be propagatable. And then finally, more granularity in the forecast and situational awareness can really help with the ability to respond, and how the physical environment in an acute sense and in a real-time sense relates to the recipient population, relates to the socioeconomic gradients within an urban environment. We've talked about granularity in terms of, you know, better forecasting and all that, but this is also clearly important in terms of how it intersects with, for example, the unhoused population, low-income populations, populations with broken air conditioners or no air conditioning. That intersection becomes crucial to the ability to respond in real time. So that's it for my wrap up. Thanks.
Okay, thank you very much, Kevin. We'll move on now to the last event, which is what we covered this morning. And we passed on to Leslie Ann, sort of the toughest job of all. She had the rapid turnaround job. So we have Leslie Ann Dupigny-Giroux, faculty at University of Vermont and Vermont State climatologist, giving an overview of Hurricane Helene and flooding. It's all yours.
I have to put this on. All right. Can everybody hear me now? Okay. And can you see me okay? Don't see me on Zoom? How many there you goes did I get for that? Okay. All right. So rounding this all up here. And of course, I do not have slides, but I do have a summary of thoughts here. And these are going to be on the brief side because of the turnaround time and all of this. So I've divided it as we've been instructed in terms of the gaps in the sciences. What are some of the difficulties and challenges that we're seeing to come forth with some recommendations and lessons learned, and then ending up with some of the opportunities for improvement. So some of the high level gaps in the foundational sciences revolve around elevating the role and importance, the spatial extent of antecedent conditions, both the predecessor events, but also looking at soil moisture and the ways in which those sort of set things up for the magnitude of the disaster, the magnitude of the damages, and the unfortunate loss of life that we see during some of these events themselves. Another big category is the issue of scale, particularly spatial scale. And we're focusing there on the small streams and the small water bodies that do a lot of the damage, that collect a lot of the water that are not necessarily gauged. and the ways in which we need to do a better job in bringing those into our understanding so that we can do a better job of how much water is actually accumulating on the landscape. The other piece that's related to that is the complex topography that we're talking about in some of these regions here. And we heard that both in North Carolina, but also in Vermont, because it sort of plays up and sets up the physics of the events as they evolve, not just from an orographic perspective, but also who's affected, where people live, and the amount of rainfall that we're seeing in some of those areas. And that naturally feeds in to the settlement patterns, which have both a historical perspective, but also a socio-cultural perspective as well. And then the third big grouping under those gaps would be in terms of the methods that are currently being used and the fact that they're a little bit dated. I think Amir talked about a lot of these events dating back to the 70s and 80s, and how do we bring into improvements in not just the methods and the methodology, whether we're talking about the IDF curves or bringing in PMP, but the need to sort of factor in non-stationarity of our climate. And while we can't rely on past events, how can we use them to sort of guide some of the new methods that we're thinking about developing? So that's the first big category in there. The second piece that we're looking at is the difficulties and challenges that we're facing right now. And one of the primordial ones revolves around governance, particularly in a decision-making perspective, but also from a watershed scale planning and implementation of the different plans that we might come up with. The second thing under some of these challenges are the socioeconomic factors that we need to be aware of, including the social fabric of our communities, the cultural dynamics and processes, the historical factors by which we have sort of set up the conditions that we experience today, who are our trusted brokers, and at what scale are they working? How do we sort of leverage the value, importance, and usefulness of volunteer networks? And then the other piece that we need to sort of also keep an eye on is that these are not single types of hazards. So we need more of a multi-hazard approach that is more process-based to allow us to sort of cut across the interdependencies among and between and within the hazards themselves. And related to that, we also need a multi-temporal approach that does not focus on this single event itself, but allows us to think a little bit more holistically from a year-to-year perspective as we're looking at some of the whiplash that we've seen in past events themselves. And then finally, under some of these challenges is an appreciation of the importance of addressing our changing climate, both from a physics perspective, so making sure that we are looking at as water vapor increases in the atmosphere, how are we making sure that is part of the modeling that we're going to be improving, the governance structures and how those play out on the ground, and then the movement of peoples, particularly moving into what have been perceived as climate havens, and then how do we actually plan for that, work through that, are we prepared from a socioeconomic perspective? So to wrap up in terms of the opportunities, we'll start off with communicating about these events, and how do you communicate about something that you have never seen, that is outside of your imagination, that even if the forecasts are perfect, you can't talk about it because you have nothing to sort of pin that to. So we're using some social constructivism there. How do we sort of lean into visualizations to make this real and make it real in real time on the ground itself? A more collaborative approach to our planning, both for the events, but actually responding to the events themselves as we move beyond just a sort of single town or single municipality type of approach to maybe more of a broader watershed type of approach, or even scaling or sharing lessons learned and resources across states themselves. Leaning into mitigation of greenhouse gas emissions, but also mitigation in a hazards perspective, because those are two different ways of talking about mitigation. So how do we mitigate the greenhouse gas emissions into the atmosphere as we talk about combating our changing climate, but also how do we mitigate against hazards and the extremes itself as a way of moving towards building more adaptation resilience? There's a huge piece around the importance of data, not just from the longevity of the data sets, so that we can place the improved modeling into perspective, whether we're updating our IDF curves or moving into probably maximum precipitation. How do we work through data in real time so that as the event evolves, we have as much data as possible to really inform if the forecast needs to be changed, for example. And data primordial, because as they feed into the models, because those would allow us to improve our models in the best input from a data perspective, and then possibly having more standardized methods, tools, and resources at the national level that could then be available at different scales down all the way down to your local level. And really, really important is the provenance of your data so that you can then parse out. There was a question about USGS data and why did it look different from the other types of data sets. So knowing the provenance of your data critically important. And then we ended with the possibility of leveraging, leaning into and using AI and machine learning to actually help streamline a lot of these questions that we're trying to answer. So that was it from that last session that we had. I might have missed a couple things here and there, but I hope I got most of it. So Brad, back off to you.
Super. Thank you, Leslie Ann. Great overviews. So we have just shy of an hour. And this is sort of the transition from, the inflow of information that we had over the last, day. And we don't have access to all the experts. So we can't, in many cases, ask back some of these questions. So I think we're transitioning a little bit towards discussion and sharing thoughts and ideas. I'm sure that the panelists would be happy to try to field questions specific to what they mentioned, but we understand that, appreciate that they were not necessarily the panelists for which the information is shared. I'm going to start out, Neil, a board member, he actually commented on fire smoke killing more. Neil, I'm going to invite you to share your thought and as a knowledge gap that you're putting on here because this is an area of your expertise.
Sure, thanks. It's just simply that we've heard that it's very likely that the health effects of the smoke from the fires are substantial, and it just in terms of straight killing people may be responsible for more deaths. But in the aerosol health effects world, the what we call the chemical composition of the particles and the influence of that on health effects remains a major uncertainty. We all know it's there. There's been a great deal of effort to figure out the elements of that, but it's very clearly quite complicated. There's not one magic element that's responsible for all the health effects. Oxidative stress, all sorts of things have emerged as parts of the story, but add into that probably the least certain source of fine particles is already burning, so it's already wildfires. And we've been working on the composition of different fuel types for a very long time. And that's very complicated because the flames are not very well controlled and such. And so even the composition of particles you get out of wildfires is a significant uncertainty. And now we're burning houses, right? So the fuel is different. And there's polyvinyl chloride in those houses, and there's lead in the solder, and all of the rest of that we've heard about. And so there's just a compounding set of things. And then finally, we know that the composition of that material evolves rapidly once it gets into the atmosphere from atmospheric chemistry. And finally, people breathe it, and there's a health effect. And so there's a great deal of quite significant, but also interconnected transdisciplinary research that needs to continue on there to actually know, someone died in a fire, it's pretty obvious. Someone died of the health effects of inhaling the smoke from that fire becomes a much more challenging attribution problem with challenging toxicology and chemistry connecting them. So that's my long-winded summary of that issue. But personally, I think it remains quite significant.
Excellent. Nice summary. Appreciate it. where, as you remove, and it sounds like a lot of this research, I'm assuming is somewhat underway and being looked at, a lot of uncertainty in the results, and as you say, it's a changing situation. How are as you remove that uncertainty, how is it manifest in the real world? Is it in regulation in like household materials? Is it in health advisories and what people should do? You know, sort of if you play it forward after you kind of tackle it and get more understanding, where does it manifest itself in the real world? I mean, in the applied world.
So historically, it's been manifest partly in the evolving National Ambient Air Quality Standard for fine particulate matter, which has got two bits to it, right? There's an acute short-term and a annual average chronic element. And again, this is probably more on the acute side. Obviously, the fires are short in duration, but that's the part of what's gone on historically with establishing that standard is that actionable sources have been understood to be part of what goes on. Now, bearing in mind that the standard is mass, right? It's the mass of fine particles less than 2.5 micrometers, and nothing to do with composition. And it's very hard to foresee a composition standard, because if you put that in the framework of the current legislation in the Clean Air Act, you have to be able to observe that composition sort of county by county in order to be able to assess whether a county is in attainment for that standard, right? So that's a very difficult lift. But there's still an understanding of that composition effect. So that's kind of where it's been, and it would have been, I mean, the fires are almost by definition accidental, right? So if you're talking about emissions from vehicles, the control, the mitigation you can put into play would be obvious. So I could see, this is just me speculating, but I could see you know, PVC is an example that comes up. I could see that it could well turn out that certain components in construction have especially significant health consequences once and if houses burn, and that might inform in areas that are just like putting a metal fence within 5 feet of a structure. There it would not be a bad idea to think about what would happen to how the construction materials would influence the smoke and the toxicity of the smoke. But that's also a lot of speculation.
Yeah. Okay, super. I don't see anything more in Slido. I do have one question. Kevin, you mentioned digital twins, and if I recall correctly, one of the speakers mentioned that Phoenix is one of the Department of Energy's integrated field laboratories. And I'm not sure if you at Northern Arizona University are involved in that, but you talked about the importance of high resolution modeling. Is the DOE IFL, are you seeing those results? And are you getting into that sort of high resolution information from it?
Yeah. Yeah, NAU is one of the three, I think all 3 of the public universities in the state are part of the Southwest IFL, U of A, ASU, and NAU. And yeah, I mean, we're running, you know, a sort of coupled global down to large eddy simulation style modeling within Phoenix. In fact, in all of the urban areas in Arizona, the 3 big Tucson, Phoenix, and Flagstaff. The digital twin is, and I think we've sort of come to that during the project where we didn't think that was something that we wanted to do at the outset, but increasingly important, not just from a modeling point of view, but from a communication platform point of view as well, since a big piece of the project is stakeholder engagement, not only with sort of city officials, but citizens, city groups. And so that's become increasingly important just as a means to communicate. And then the other part of the project that relates to the high resolution is then our ability to simulate, to do not only diagnostic modeling, but prognostic modeling as well. Be able to look at, some of the solution space that was mentioned yesterday, things like cool pavement and shading, roofing materials, et cetera. Seeing what the impact is locally. And again, that just demands a lot of granularity to be able to properly model the implications of materials and changes at the surface. And then, as I said in my summary statement, and then equally important is that sort of has to be then almost co-mapped with the gradients in socioeconomics, in housing envelope viability, all that very fine grained, almost building by building features, so that you can then look for the most susceptible, most vulnerable populations, and the places where solutions are also, you'll get the biggest bang for your buck, so to speak. So that granularity comes in a few different places. I don't know if that answers your question.
Yeah. Thank you.
Slide O here.
I don't see anything more in Slido. Other thoughts from the board here? I will give first opportunity to the board members. Trying to figure out Neil's comments here.
Jonathan had a comment
Oh, there's Jonathan. Okay, I was trying to figure out this. Okay.
I'm trying to get him to speak up.
Yes, please, Jonathan.
Oh, no, I was just concurring with Neil's comment about the toxicology and particulate matter speciation. What are these particles? Certainly the size is one of the most important, just that they're PM 2.5, and that's bad news. But I need to reread this paper from Pediatrics that shows that wildfire smoke PM is 10 times more harmful to very young children than other sources of PM. So I need to see what the other sources were, but that study shocked me, that what the heck is in this wildfire smoke that's so harmful to kids. So I put the link into the study.
Okay, thank you. Thank you, Jonathan. Okay, I see Kevin, you have your hand up.
Yeah, I was just in following up on their question about, if once we do more of the kind of post-fire air quality work, what can be done? I was also struck by, in the presentations yesterday, this idea of just the sort of post-fire timing, the return of resuspension of particles. And it just seems that there's maybe another policy intervention there where, we may gain better knowledge about when is a viable return time to places that have burned. Maybe just better understanding of the resuspension, what happens after the fire event's done, but still can have health impacts, and what that timing is and how long that lasts and what it's related to, so that you can better target return times to different fire situations. Seems to be another key piece of the puzzle in terms of what you do.
Jen Queen. Board member. Yes, no.
I don't know if my microphone works. Can you hear me?
Yes, I hear you. I don't see you.
Okay. Somehow, oh yeah, I know why, because I'm not using the camera. Anyway, so I really impressed by Minhui's summary of the fire stuff. And I just wonder one thing, what always puzzled me. I did a lot of fire work, but I found that it is really, really difficult to suppress fire of that kind of magnitude we have talked about, especially after fire started and after the initial stage. On the other hand, as Minhui's summary showed that those fire almost predictable given the 4 factors ahead of those big fire. And I wonder, given LA and the other state have put so much money effort into the suppression of fire, whether we have done enough to prevent or to suppress fire at very early stage, if we can do a good forecasting of fire, at least of the favorable condition when fire might occur. But of course, fire's ignition is kind of random. Nevertheless, if we know there is very high likelihood of fire given the next few days of weather condition, can they do much more to to start preventing fire or to suppress fire at the early stage? If this has not been talked much, what action could be taken in the very early stage or even a few days ahead of time? That's my comment.
Great comment. And there are probably others in the room who can speak to it more clearly. I do know that is an effort that they're making as far as they have the Santa Ana forecast or different fire risk gets elevated, they start shutting down high transmission power lines so that they don't minimize on the fire strikes. I know there was a lot of back and forth on the LA fire on whether the fire start was from the lines and whether they should have deactivated the lines. So there is certainly a tension in that area. I imagine it is something that could be improved, but I don't know, is anyone aware of sort of successes in that area where they really feel that they've mitigated or prevented fire losses, where they shut down a power line and it subsequently blew over and there were no fires? Any board or other comments on that? Okay, Kevin Reed, you have your hand up.
Yeah, and I'm taking the conversation maybe in a slightly different direction, but one of the things that I kind of saw as a connection across the sessions, and maybe even going back to some of our board discussions leading up to the sessions, is related to I think we heard a few times, right, that communication of weather forecasts or of weather and climate information isn't just enough, right? That the translation of the science in order to inform not just preparedness or emergency response, but kind of the building of resilience into these communities, either after these events or for other communities to that were maybe near misses, right? It was just one state over, and what happens if Hurricane Helene was more in Tennessee versus North Carolina? And so, I think what I've heard some is that it's more of a coordination, more in depth with practitioners, I would say, or practitioners in industry and local governments more generally. And it's not just, oh, here we've provided this updated IDF curve, right? Now you'll know how to use this. And I think it's actually, there's a broader need to start to think about how we can map the science and the modeling and the data sets onto the types of tools that practitioners use, right? So a good example of this, I think, and we saw some of this in some of the talks, is related to risk assessment, right? And so that's one way, and there's whole industries that focus on risk assessment for different type. I think if you look at water resource managers, they often have design storms or storms of record that they use for their planning purposes. And how can we build more up-to-date climate information or weather information into that? I think an example I often use in my own research is that, if you're a water resource manager, say, in Florida, or I'll just use California, and you do dam operations, right? If your storm of record is something that happened 50 years ago, then it's important to understand how, given the non-stationarity of climate, that event that you've planned your system around is maybe now different if it was to happen in 2025 or 2026. And I think that that isn't something that just happens overnight either. I think that a lot of these, and we saw some of the good examples, I think, in the wildfire examples yesterday, is that it really takes a long-term coordination, relationship building between scientists or institutions with those practitioners, with those local agencies, in order to develop the trust, but also to start to speak the same language and start to, be able to translate the state of the science into a use. And I know that's a broad statement, and I think not a new statement at all. I think we've had similar discussions on this board in the past around this, but I think that the usability of science kind of remains a significant challenge because, and I'll finish with saying it's a challenge because we can't, we can give really good examples of how it's worked well, but we can't do this for every single industry, for every single practitioner group, for every local government, because that is a very large scale. And so I still think that the community, a challenge that I see across these is that we don't necessarily, and I could just be naive and ignorant of some other good examples, but I don't think we have a really good framework for how to broadly do this. How does a scientist that studies atmospheric rivers at UC Davis, for example, how did they, start to develop the skill set and the tools and the ability to work more directly with locals in their area? And I think that a lot of our colleagues that are based at universities or at national labs, right, are very much, I think we even saw this, all the folks that we talk to are regional, local to where the impacts are, right? And so I think it's in the nature and the DNA of research universities to want to, help for the betterment of their local region and communities. And I think that we still lack a lot of frameworks for how to maybe do that. And so that's a broad statement, but I think that that's kind of a unifying theme, maybe for us to kind of consider discussions on in the future.
Yeah, that I think cuts to a lot of the core of some of the challenges we talked about. We had several speakers mention the importance of trust, and we saw sort of, and I think overall, we really are during a period of time where there's just this increasing lack of trust. There's a degradation in how people look at science or how people look at the role of government. And it really prevents that transition from research to applications and where we really need it. You mentioned atmospheric rivers and someone studying it and how does it get into operations. I know Marty Ralph at Scripps in his center has worked hard at exactly doing that. And they have a reservoir management system now where they're looking at early, antecedent conditions and what's going on and how far upstream atmospherically the threat and how much they can let out of the pool or keep in the pool with good success. But I know that that's been, like a decades long, high energy, lots of relationship building, as you mentioned, Kevin, getting out there, spending time, showing the results, working side by side. So it doesn't scale maybe easily, but I think it is productive. And I think you've hit on a lot of the critical points in why that effort has been productive.
Yeah. And so maybe just to add something really quick, which is I think an opportunity in this space is actually around workforce development of our early career scientists, or even not, scientists, whether they're undergraduates, masters, or PhD, and that I think that there's an opportunity for a lot of our universities and departments to start to make sure that those type of skill sets of communication, science translation, relationship building are actually part of the curriculum for Earth system scientists and meteorological scientists, because I think that that's an aspect where, right, it starts from giving them the skill sets so they're comfortable earlier on in their careers and engaging in these areas.
Yeah. Thank you, Kevin. Bernadette. Yeah.
Sorry, my video is not working. You said what Kevin just said was a lot of what I was thinking too. So it's really to build upon that, because this is where I spend more than my working time and energy and thoughts on. communication means a lot. It's really information sharing. And that plays out in so many different ways. It's how we translate science, the kinds of words, it's who we include in the conversations, how we include them, what platforms we use, the kinds of content we use, how we get attention, especially in a time when our information systems are so fractured and all over the place and changing really rapidly. Also trust within that too. So there's a lot that you can build upon when you say communication. And this what really comes back to the power of trust, the power of partnerships, relationship building. It is so critical in actually getting actionable information to people when and how they need it. And it starts way before events. A lot of the work needs to be done so that it can work during events. And then it's how we build back better in the future too. So there's a whole line and bridge around this that plays into it. And a couple of other things I want to say that it's not just for us to think of on our own either, because when we truly engage with our communities and listen to them, it informs us better in how we frame our work, how we time it, how we communicate it, how we release that information. I mean, we have so many different examples of how we could do this. But one thing that I was even thinking about when you were doing the flooding events is the Ida event when it moved through New Jersey and New York. Because, I mean, there's many events that stick with me, but this is one that really sticks with me in life of an amazing forecast in an area that had tons of resources, and it failed miserably. There were over 30 people in New Jersey who died from flooding. At the same time, we had a massive tornado come through and no one died from that. So how information's getting through in which ways? I mean, there's a lot that plays into that. It was coming out of a pandemic. People were exhausted. It was going into a holiday weekend. There was a new government that had just shifted over in New York. So even though there was a good forecast and some people got that forecast, what does 3 inches of rain in an hour even look like? And our systems are built from so far beyond, let alone where we're going. So they can't even keep up with that. And it's really hard to help people understand what that means. And then you add the layer of apps, weather apps on top of all of this, which really hasn't come up in this conversation, but people have been trained on them. And I've had a lot of thoughts of this over the year of how we actually share information through our apps too, because if it's just an icon with a brain, how's that genuinely conveying that your car is going to float away while you're driving home today? So there are a lot of layers to this that fall under the concept of communication, and these types of collaborations start on events like this. I really encourage people, if something stood out to you, or if there's something that piqued your interest, all of our speakers would welcome you to reach out, to continue a conversation. Think about bringing them into some project you're working on or some future event you're doing, because that's how this happens. And then we can keep building upon events like that. So I just wanted to kind of add on a little bit more to what Kevin was saying there. There's a lot we can do with this. There really is.
Yeah. Thank you, Bernadette. Yeah, a lot of great insights for sharing. Thank you for sharing. Stephen, Sector National Academies.
Yeah, mine is also building on Kevin's comment, and in talking about what are the communities we reach out to, but also thinking about what are the other science areas we need to be connecting to. Listening to Ken and Kathy talk about seeing those numbers and even themselves having difficulty foreseeing what that meant in translation to the real-time effects. My mind first goes to, well, we need models that can immediately turn those rainfall estimates into flooding, but then they're already hearing about people weren't connected. They were already cut off at that point in time. And so I think we do need other connections with other communities. I'm not sure that the thing that immediately jumps to mind is the things that we need to implement, but Effie brings us always back to the hydrologists and the connections there. And I think that we have some opportunities in connecting with some near partners in our work to think together about what we need to do to provide people the information they need.
Yeah, thank you, Stephen. Yeah, a lot of issues and clearly coming to various information trenching. How do you get it out to the right people? Effie.
Yeah, I wanted to add, I don't know, that from the science point of view, I see that we are in a junction that we need new paradigms. We've talked about non-stationarity. Non-stationarity is taking place now in many ways. The changing character of precipitation and the extremes. I mean, these are dynamic. You cannot incorporate in the old way of non-stationarity through statistical approaches. Non-stationarity in the compounding, I mean, the events interact themselves in a non-stationary new way that we had not seen before. Non-stationarity in the scales of interactions. We have the very large scale events, atmospheric rivers or other events, and then they create non-stationarity in the timing of the storms and the time that they stay over the region and so forth. So in my mind, I have that, you know, of course, the communication is very important thing, but we have to just change the paradigm of putting together our knowledge of physical modeling, the compound events, yes, taking it from precipitation down to hydrology and all the hazards and so forth, and kind of creating a new paradigm by which possibly AI can help us also translate this quantitative assessments to something that people can resonate with. Can I, for example, use, now this is speculation, AI to translate the 3 inches of rain in, you know, in 15 minutes to a car not being able to drive on a street? I mean, would that resonate more with someone that is deciding to take their car or not? So what I try to express here is that scientifically, we're at the junction that we need new research paradigms, putting all together the physical scientists, the statistical scientists, hydrologists, atmospheric sciences, economists, social scientists. And then the communication part will just wrap all this together with new ways of presenting, I don't know, in a visual context, all these concepts that science, you know, has told us. So I don't know if I get the message across, but this has been a very interesting 2 days, a lot of excellent discussion, but how do we move forward? That's what it kind of concerns me. We should not stop here, and there is a lot to do. Thank you.
Thank you, Effie. Yeah, more and more pressure, direction to, it used to be interdisciplinary, extradisciplinary, interdisciplinary is more and more necessary as we talk about all these sciences through this pipeline and this flow of information. In Ming Wei's presentation, she mentioned, you know, science into practice. One that struck me through a lot of the last day had to do around the built environment, and both, you know, the great example that we'll all probably carry around with is this reflective pavement issue where it kind of didn't, the right information to get to the right people. And where I'm going with this is the decision makers and making sure the information gets to those decision makers. In that case, it was information getting to apparently the, you know, the government's board of the city, and they had some information presented and the news came in and it kind of derailed that effort. And they said, no, this is a bad thing. It's going to make it hotter and we'll stop. It gets down to Ming Wei as far as like in the fires, where do the people understand that for an investment of $3,000, they can retro fit their homes, and maybe in these high fire risk areas, that is information that's communicated to the residents. So who owns those decisions, and is the right information getting to those decision makers? And it's hard for me to believe that a lot of these people, especially after seeing these devastating conflagrations that just run through neighborhoods and communities, if they knew that there was sort of an investment opportunity to at least mitigate it for their own and maybe overall with these built barrier, fire break barriers that were mentioned. Do they know and do they have that opportunity to vote on something that allows them to invest? I just don't think the information's getting down to those people who would be are the right decision makers.
So could I respond to that a little bit, Brad?
Absolutely. Yes.
So I think it's a multifaceted challenge that we're looking at here. And I'm going to turn my camera on so that folks can see me. And part of the challenge with it being a multifaceted problem is that as Effie was saying, we need to sort of shift the paradigm a little bit and shift the paradigm from scientists talking to scientists talking with. And the power of the panels that we saw for the last 2 days was the sort of breadth of who's in the room, both virtual and online, in the experiences that were brought to bear and the stories that you were hearing from all of the various folks, and a lot of the parallels that were coming out, but a lot of the sort of pieces that we don't always think about. So for example, we don't always think about doing things at a neighborhood level or doing things at an individual level. And if we really want to sort of make some of those shifts, it's not just talking with or talking to state agencies, for example, but it's also talking with neighborhood network groups, but using trusted brokers who are already doing a lot of that on the ground based type of activity, so that we don't just show up, but we walk with. So I think we have to change a lot of those prepositions from the to the with and the among and so on to really make some of those paradigm shifts if we really want to move things forward.
Thank you. Other thoughts? I haven't looked at Slido recently. Let me check there. Anything going on in the Slido world? Where did it go? I don't see it. Is there anything in Slido that I'm missing? I must have lost my window. Is it? Yes. Oh. Okay, great. I'm sorry.
There are a couple
yes.
of comments in the Slido about some of the existing literature about decision making. So I think there's another set of communities that not only the physical science communities, but folks that are working in deep decision making under deep uncertainty, as well as whole sets of literature. There's one paper listed in the Slido about stakeholder engagement for decision relevant research. So that good reminders of other communities to be engaged with who have real science evidence-based information to inform what we're doing.
Great comments. Does Atul ask about public lands and what new practices for managing public lands are being explored as it relates to fire and erosion? Is anyone familiar enough to speak to that? It's certainly an important topic and one I would assume is getting some attention, at least at the state and local levels. Anyone have any comments there? Stephen, yeah, thank you. The DMDU Society, decision-making under deep uncertainty. That sounds fascinating. Don't know anything about it myself, so it's fascinating to me as well. Something to look at. Anyone have comments there? Okay. And Virginia, thank you for sharing the paper, Trammell. It's really important. Well, maybe everyone's hungry and ready to go on to the rest of the day. I'll just share a few thoughts and then I'll ask Casey if she has any final closing comments. It's been a great time. This, again, thank you for joining us for the board's open session yesterday afternoon and this morning. It's really important to us, and likewise then to the academy, that we hear both from the experts and in this case practitioners and survivors, so that we can learn and that we can take that information forward and play it forward. We've had a great turnout, over 100, I think, throughout the event, and upwards over 200 at any one time in some cases. So thank you for sticking it out. Even though, so it's a virtual community, and, challenge each of you to take this information that we've shared over these last 2 days and think about how you can help and move this forward. It's important to the society. There are clearly dramatic impacts. We know these impacts are increasing and becoming more severe. So whatever we can do, both as a board and national academies, but most importantly and beyond, is just the community and you and all in whatever role and place in life you are, how you can help tackle these really critical problems moving ahead. So just a big thank you to everyone, the speakers, the planning committee who put this open session together, the rest of the board, and certainly the National Academy's staff. So with that, I'll pass it over to Casey and thank her again for her leadership as director of the board of BASC. Yes.
Great. Thank you, Brett. And thank you all. We're grateful that everybody was able to join us over the past few days. And I just want to really echo Brad's thanks to all of our speakers. We really appreciate your contributions to the case studies and the way you were able to bring in both the science of these issues and then the human dimensions, which is what I think really draws us here together to address these issues and the critical importance of moving ahead with the science and the connecting the science to society on them. So thank you to our panelists. Thank you to our moderators and our organizers and our staff and our BASC members as well. This recording will be posted so you can rewatch or share with people, and we'll continue to make our activities available to you. So thank you all for joining us for this session.